Hello and welcome to the fifth year of NahamCon. My name is Ben Sadegipur, but most people online know me as NahamSec. This is our fifth year, as I mentioned earlier, and we're doing things kind of similar as last year, but I think this has to be one of our best lineups, both with our workshops and with our talks. So if you're not familiar, this is your first time joining for NahamCon. Every year around this time, we host NahamCon as a conference. It started 5 years ago as just something that me and a bunch of friends wanted to do during COVID because we were all stuck at home and we couldn't go to any conferences. And it has stuck. It has stuck ever since. So we're here for our fifth year, and during the recent years, we have introduced a first day and a second day. Which the first day is always our workshops, and the workshops will. Let me remove that real quickly. The workshops will have a more in-depth during the first day. It's more in-depth on specific topics. So the first one is our CTF. The next one is going to be around doing some WAF stuff. Then we have WordPress, and then Tibbs is going to close out the day with some SQL injection, or as I like to call it, SQL injection, just to trigger people. And we'll wrap up day one, and then tomorrow we'll do our day two of NahamCon, which is pretty much talks. It's shorter talks, maybe around 20 to 40 minutes each. They're not as in depth, but just they're supposed to be shorter to just cover a specific topic. So, with that said, I want to welcome our first speakers. They're going to be doing a workshop around how to do CTF. How do you get involved with the CTF? How do you solve and find the flag? And how do you submit it? And if you have been a part of NahamCon, you know our CTF is one of the biggest CTFs, if not the biggest online CTF that we've seen around. Currently, we have about 6,000 people participating. And unfortunately, that's my phone. We have 6,000 people 6,000 people participating, and a lot of times when we have these new CTFs, people are new to CTFs and they want to learn how to do it. So they also try to learn, and it's kind of harder to get into CTFs. So we organized this workshop first to kind of give everybody a quick introduction to CTFs in case they want to participate. All right, enough about that. I'm going to bring up our other host, Micah and Sonia. I'm just going to bring them up to the screen right here, and they're going to take over the stream and do a little bit of a walkthrough. I'll let you guys introduce yourselves and take over from here. But also, if you're participating, there's a link down below. Make sure you go there and register. The stage is yours.
All right, well, welcome everybody. Glad to have you here. Sonia, you want to start with some introductions here, and I'll go ahead and add my screen. There we go.
Oh, hi, welcome everyone. Welcome to this CTF 101 workshop. I'll leave Micah introduce himself first.
Hi, well, my name is Micah. I run a team here at Sneak, and we do a whole raft of different kinds of workshops, including this one we're going to present to you today called CTF 101. I'm a developer mainly in Java since it was released in 1996. That is 29 years ago. I can't believe it. Java just celebrated its birthday. But I also have always done security and programming in other languages, and I love doing these kind of talks, and we love NahamCon. So welcome, everybody. And Sonia, why don't you go ahead and tell everybody about yourself a bit?
Sure, I'm Sonia. I'm a staff security advocate at Sneak, working with Micah and the amazing Devil team. Really stoked to be for the second year doing this CTF 101 workshop with you all.
Sweet. All right, well, here's our agenda. So we're going to give a little bit of an overview about how to get started with CTF. And I kind of want to say out of the gate that we're not giving you, this is more about learning to learn in a way. We're not giving you like direct answers. We're giving you some of the sleuthing tips that will help you to participate in CTFs, kind of that critical thinking piece about thinking outside the box and probing around the edges of systems and what might be going on that is kind of behind the scenes. And that's really the keys to participating in CTFs is not a very deep domain knowledge necessarily with a particular language or protocol or database. It's kind of the generalized skill of being able to figure out puzzles in a way. So we're going to present two specific challenges. One happens to be, I forgot what it is. I think maybe it's Python based. One is Java based. It has containers. It kind of doesn't matter what the language is, because we're going to be, the goal here is to get the system to reveal a flag to you, and to to kind of move quickly through it. And then we're going to have a bunch of resources at the end that'll help you to continue your journey with capture the flag events. So getting started, what is a CTF? Well, we've probably all heard the term at this point. Maybe you're participating in Naham's great CTF. But what's the point of it really? It's to simulate these real world security challenges in sort of a safe way. And unlike, the general world, you're being invited in to perform different types of attacks or hacks on systems. And so you're presented with a series of challenges, and these kind of model real world threats. Sometimes it's using a vulnerable library, something that's known to be vulnerable. Sometimes it's a particular way of crafting a request with a particular protocol. There are several different types of challenges, things like binary analysis, web exploitation, crypto, as in cryptography, not as in currency, reverse engineering, network security. And it's different from other disciplines like penetration testing or vulnerability assessment or even ethical hacking, because you're kind of working in this sandbox. You're not out in the real world, but it is designed to kind of mimic the real world. Now, if you've never participated before, you may be wondering what's a flag anyway. It's just a little bit of digital signature that tells the system that you did the right thing to solve the challenge. And in our case, this is the format of the flag. It's going to be in all caps sneak, followed by a set of curly braces with a long hex string inside. And if you're like me, you may be thinking, well, maybe this is a real flag here. What I would do, because I kind of like, I have this chaotic mindset, which is really, to picture the chaotic mindset, it's like a squirrel running on one of those aluminum wheels in a cage. That's kind of like the way my mind is. And I might be inclined to think maybe this is a flag right here. You don't take my word for it. It's not a real flag, but that's the kind of thinking that, you might just take a screenshot of this and see if you can drop it in, and maybe it would solve a challenge. In this case, it's not, but, definitely don't take my word for it. Now, preparing for CTF challenges, getting set up, you want to sort of have a toolkit at your disposal. And, there's some common tools which we're going to talk about. Having some Linux proficiency will be useful. It's not always the case that it's going to be running on a Linux server or a Linux-based challenge, but most of the modern web, most of the modern publicly available applications are run off of Linux. And there are a bunch of really good hacking tools that are Linux-based. Like you might have heard of Kali Linux, for instance. That's a thumb drive distribution that gives you all kinds of hacking tools that you can just pop into a computer and have at your disposal. CTF platform enrollment. Most CTF events and platforms will have or will require you to register and authenticate in some way. It's usually not for any, kind of weird marketing purposes. It's usually just so that you can be on the scoreboard and track your progress through the CTF. And it's important to understand the rules and objectives. There's kind of a baseline, kind of certain expectations with any CTF that you participate in, but different CTFs will have different rules. Some may require you to work on teams. Some may allow you to work as individuals. For our purposes, the CTF that we're going to be using today, everybody can work as individuals. So a couple of do's and don'ts. CTFs are really kind of a social event in a way. Like it's exciting and fun. People share their progress and they talk about what they're up to and where they're stuck. It's really okay to share your progress, to ask questions, to talk to each other for clues. And if you're looking for a specific clue or very specific information, that's when you might go off into a private sort of chat area, because it's really important to not drop spoilers. And that's everything from the flag itself, like never drop the flag itself into a public chat, but even kind of hard, if you're unsure, take it off to a private area of the chat environment associated with the CTF. But it really is great fun to share your progress. Oh, I just got this flag for this problem, and then you might get a whole flurry of questions about how you did it and where people are stuck, and you can use your own discretion in helping other people out. But it's that kind of makes it fun. Also, very important, this last thing, please do not hack the back end. Most of the time, CTF systems are running kind of on lean hardware, either real hardware or out in the cloud. They're not meant for the typical things that we would expect out of modern applications. They're not meant for failover and high availability. And the point is, you're never going to get a flag by bringing a server down or by launching a denial of service attack. That's never going to yield a flag. So there's kind of this implicit agreement that we all have where we're not hacking the back end. We're not looking to bring the system down. We're not looking to bring a challenge or a whole server down. That will never get you a flag. And etiquette wise, it's kind of a violation of the rules to go and hack the back end. All right, so we have a Discord where you can chat for this particular CTF that we're gonna launch into, and this CTF is gonna be up for some time. The challenges, we're gonna cover 2 of the challenges today. There's a total of 4, and you can feel free to do some of the other challenges on your own. And this Discord channel is durable; it'll always be around, and we'll make sure to answer your questions there as well. And Vandana is part of our team. She's awesome, and hopefully she will drop that Discord link into the chat very shortly. All right, so CTF tools, we touched on some of these. It's really good to have a number of these different kinds of tools in your quiver, so to speak. And if anybody recognizes these tools, drop them into chat. Maybe you've worked with them before. We're gonna work with some of them today. Over on the right-hand side, we have Burp Suite. We're definitely going to see that today. But they do different things. Nmap is for discovering vulnerabilities on networks, things like open ports. John the Ripper is for things like cracking passwords. Metasploit is a whole kind of suite of utilities that's ever expanding for different specific types of attacks to exploit certain vulnerabilities. Any others that you recognize? Yeah, I see a few of you out there. We got Kali. I spoke about that a little bit. Burp, Nmap, very good. I like that in professional settings I get to say burp a lot. Thank you, Burp Suite, for that. Now, it's not a requirement at all today to use Sneak, but it will give you an advantage or yield some clues in some of the challenges that we're going to do. So you can always go over to sneak.io and create a free forever account and grab some of our tools. Again, not a requirement, but it will give you a leg up if you're interested. So just to review tools, you're going to want to have some sort of a text editor. It might be useful to have Node.js and NPM installed, not a requirement. Burp Suite Community Edition will be very useful. It's free, and I'll be demonstrating that a little later on. We already gave you the link to the platform, but here it is again, 101.ctf-sneak.io. You can go and create a free Sneak account right at this coordinate here, sneak.co/NahamCon. And then if you want to grab any of our tools, that'll help you also, not a requirement. All right, last thing before I turn it over to Sonia for our first challenge is just some strategies and techniques. And that's really the focus of why we're here today. We're not here to teach you about, the finer points of Burp Suite or the finer points of, making an HTTP post. Really, we want you to start thinking in terms of, how do I identify the problem? How do you identify the problem? What is the problem that you're being asked to solve? And one of the things you'll see is that sometimes within the challenge itself, there are clues that you can pick up on. So you can gather information, analyze those clues, and before you ever go to a website or start, sending packets of data, there's a lot of information to gather and a lot of clues within that information. You want to know, like, what kind of language are we talking about? What kind of protocol are we talking about? Is there a database involved? Is the server protected? Does it accept requests other than HTTP requests? So a lot of that you can get right from the challenge information itself. Sometimes there are riddles within the challenge. Sometimes the name of the challenge itself will give you some sort of clue, and you want to kind of compile all those together, and then you can start testing and iterating. And there are some common mistakes to avoid, which we're going to go into in more detail as we get into the challenge. But one thing I would say, especially in the context of a CTF, is you want to be aware of rabbit holes. I have certainly, and sometimes challenges, especially tricky ones, are designed to send you down a rabbit hole where you end up wasting a lot of time thinking you're on the right track and you're not. So it's kind of like test taking. I don't know, everybody's got their own kind of approach to test taking. What I tend to do when I participate in a CTF is I go over the entire list of challenges and I start to look for ones that I already know I know a lot about. So if there's a Java challenge, that's going to be first on my list. If there's an HTTP protocol, if there's an OAuth challenge, like I'm gonna check those off first and see how far I can get with them first, because that I have domain expertise in those. If I know there's like a Python challenge or a Haskell challenge, or maybe there's like a NoSQL challenge where I'm not so well versed, I might save those for later. So we'll talk about some more of these mistakes to avoid, but definitely beware of rabbit hole and kind of work to your strength. All right, with that, I'm going to stop sharing my screen and I'm going to turn it over to my colleague and friend, Sonia, and you're up. Take it away.
Thanks, Micah. So let's start with the first challenge, because I'm pretty sure everyone is quite excited to start coming up with the CTF. So the first one will be File Explorer, and if you navigate to the platform, you'll have to go to click on the little challenges tab, and this is where you'll have the 4 challenges. But today we're only going to go through 2 of these challenges. The first one is File Explorer. So usually with CTF, you have a little bit of info on the first card for the challenge. So here we can see the name of the challenge, File Explorer. We can see the number of points, which usually gives you an idea of the complexity or difficulty of the challenge. Here we also have a little bit of info on the programming language or the ecosystem. In our case, it'll be Node.js, apparently. Also talking about Sneak open source. Okay, so let's keep this in mind. Here we have quick description on the challenge, which is exposed hidden files in the web application. Okay, we do have a link, so we'll have a look at it in a second. We usually have also hints, so it will depend on CTF. Sometimes when you click on the link, it will actually decrease the score that you have. But here it's fine. Hints are free, so you can have a look. And here apparently it's a GitHub repo. We'll have a look at this later on. So now at the moment, what we have is we have the URL, we have the language, well, the ecosystem. So we know it's JavaScript and Node.js. We have the files also, which is a GitHub repo, and we have this cryptic sentence: expose hidden files in the web application. So let's have a look at the website. So that's the website. Cool. So go ahead, hack me, find the flag, take a look at our files here. So we're in the kind of reconnaissance phase. We want to have is actually gather information on the website or the application, so we can try different things on it. And I can ask also the audience, still in the reconnaissance phase, what would be the thought process? Where should we look at? What should we do first? The reconnaissance phase, we're not probing with the website directly. We're just trying to find some hints and more info on the website. Any thoughts on that? What we could do? Well, I'm looking. I can actually look at the page source to see if there's any. Sometimes the flag is hidden on the source, so I'm looking at it. Nothing interesting. apparently. So yeah, I can also have a look at the dev tools, and sometimes I can look at the network tab. I can look also at the elements, just have a look at some if there's anything hidden. So those are usually good places to have a look at. But here I'm just going to have a look at the link and see if we can progress on that. So take a look at our files here. Okay, interesting. So we do have access to the /public folder, and we do have access to a couple of folders and files here. So we do have the CSS, the JavaScript, the robots.txt. Sometimes you might also find some interesting stuff on the robots.txt, which is not the case here, but we'll continue. So having a look at the JavaScript file, just Google Analytics tag. Okay, what else would you have? CSS files. Okay. Not really interesting. So cool. So we had a look at the link here. We know that by looking at the hint, there is a link to the GitHub repo. Maybe we'll find other things, other more interesting things, potentially the flag. So I'm going to have a look at the GitHub repo. And what I'm going to do is actually git clone the repo and have a copy on my local machine. So I've done this. Also, there's potentially a good hint on the README file. Simple app, just using st library. Okay, can keep this in mind. So let's have a look now. What do we have? So I did git clone the repo on my local machine, and I'm having a look at what do we have. So we do have the public folder, the one that we've seen with the link on the applications, and didn't find anything really interesting here. So let's have a look at the other files. So we do have the index.html, which is just the page that you're seeing here, the one before that. So nothing fancy here. Let's have a look at the app.js file. So what do we have here? Maybe something a little bit more interesting. So at the top, because this is a JavaScript application, so we do have all of the modules and packages at the top of the screen. And then, sorry, you can't see the I'm sharing the screen. Yeah, thank you. So at the top, you have the packages. So you have st. This is to serve static files. You have Express. This is the framework for JavaScript, and then you have HTTP to serve the requests. Okay. Then we are creating an instance of an application using Express, and we're calling it app. So we're setting the ports. Okay. Then we're serving one of the routes with the /home with the index.html, which is this one, and this is what you have here. So nothing really fancy here. Let's see this static file. This is how we serve static files with the st package, and we have access to the public folder. Okay, and then we just serve the application. Okay, that's maybe we can find some interesting info here potentially. But let's have a look at the third one. So we have the package.json, and the package.json is a manifest file for JavaScript language where you do have a lot of metadata about the project. You have a couple of scripts as well, and you have the list of dependency which are used in your project. So here we can see a couple of dependencies. So I would assume that as a developer, don't have visibility on what is going on. Apparently there are some vulnerabilities that we could potentially leverage. So what I'm going to do, I'm going to use the Sneak tool. So I'm typing Sneak on the extension. I'm using VS Studio Code at the moment. So I'm just installing the ID integration, reloading the ID to take it to account. And you have this little patch icon on the left. The first time you won't see any of the vulnerabilities. Patch will ask you to authenticate. So if you have free Sneak account, you can do so, connect, authenticate, and then you can let Patch catching all of the security vulnerabilities like he did here. So let's have a look. What do we have here? Interestingly, we do have a few vulnerabilities. So let's have a look. So Express, and we do have a couple on ST, including one directory traversal. That's interesting. Let's click on that one. What is this? So you have that within your ID. You have the name of the vulnerability, also when it was introduced. So this is the version of the package that we do have here. Cool. We do have a proof of concept, which is great, because usually when you're doing CTF, you do want the proof of concept in the documentation or in a blog post or in this kind of information to take, to leverage, to craft a better payloads, but you have something that you can use. So here we can see that the version prior to this version didn't properly prevent path reversal, and we do have a POC to use. Okay. And for those of you who are not aware of what is a path traversal or a directory traversal attack, this is aiming to access files and directories that are stored outside of the intended folder. So we need to manipulate the files with the .. sequences or its variations. Okay, so let me try with the .. This is not working. So we should be using variation. Okay, let's go back. What are the variations that we could use potentially? So directory traversal will lead to information disclosure. In our case, hopefully it will lead to the flag. That's our hope. So ST is a module for serving static files, and apparently it does have this vulnerability. Cool. There's a little note here that if we use the %2e URL encoded version of dots, potentially we can bypass this. Cool. So I have the URL encoding for the dot, but what is the URL encoding for the slash? So what I'm going to do is just, usually when you're doing CTF, there's also a little bit of exercise with learning and Googling stuff. So here I did a little bit of Googling on the URL encoding, and I did find the dot is %2e and the slash is %2f. Cool, let's do this. So I can do the %2e and %2f. Oop. Sorry, in the public, not here. Cool, and now I do have a lot more on it. So, and obviously you can see an interesting information here. So, well, I'll let you do the little trick with the %2 and %2f. So while you're looking at the flag and finding the flag, copy pasting it on the here on the little window here where you should submit the flag, I'll give you 2 other ways to actually find the flag, because here I've actually found it by manipulating the URL through the browser. So there are also a couple of ways you could do so. For example, using Postman. So I'm going to create, I have the extension here through the Visual Studio Code, but you can also have Postman on it. So here I'm just going to copy, just going to go back here. I'm just going to copy this, go back here and send the GET requests. And obviously what is back is the same as we were saying. And I'm going to do a little, same little trick with the public and the %2 and %2f. And obviously, because we're just fetching request, this is going to come back with the flag here. So you can also do it through Postman, which usually it's the tool that developers are using. Maybe we're not thinking about using it if you're doing ethical hacking, but this is potentially one way because you can capture a GET post request on it. So that's another way to do it. You can also use curl. So by using curl with the URL, you can just fetch it, and you can do the same with the public, and then %2e and %2f. Oop. I got it wrong. But when you're doing this, you can also fetch it as well. There's like 3 ways to do it. If you want to do it through the browser, through curl, through Postman as well. And while I'm still I'll let the people also find the flag for 1 more minute before revealing it. And there's another way actually you can do so. You can also go through Sneak Advisor, which this is also a free platform where you can actually check the npm, PyPy, Go, and Docker ecosystem. And here we're looking at the ST package, for example, and see if there's any vulnerabilities. So clicking on the ST package, usually we can see if there's any security vulnerabilities here, and looking at all the version, we're looking at the specific version that we had within the challenge. So our version, if I'm looking back at the package.json, it was this version. So I'm going to have a look at the 0.2.4. And here also you can see a couple of open redirects and the directory traversal. Obviously, it's the same kind of info that's coming for our database, and you still have the same proof of concept, but this is also another way to find some good information also to capture the flag. So I think it's time to reveal the flag now. So I'm back with this /public /%2e, %2e, and %2f. And here's the flag. And that's the flag. So I'm going to copy this little flag and put it here and submit it. I should be able to get 100 points with that. Cool. So what did we learn? So to have a look at all the files that you have during the challenge. So here we had the website and also access to the GitHub repo, which is great because sometimes you don't have access to the all the code base, but here you had access to it, and you need to have a good look at the code and try to have a general understanding. You don't need to be an expert. And if you think that this is a little bit too much actually to digest the app.js, you don't really understand what is going on, what I did is actually I did copy the code, and this is a try with ChatGPT for the Omni version. So I'm doing a CTF, I have this piece of code. What can be a good entry point to find a potential flag? I copy paste this, and look, what did I get? The first file inclusion and directory traversal. That's a great hint, actually. So it might be useful to leverage LM to help you solving CTFs. Just an advice. You can also, as you've seen, using Snyk to help you solve the challenge. If you do have the piece of code on your ID, you can have Snyk code or Snyk open source to give you that visibility and find some vulnerabilities within the package that you could leverage. And you can learn more about path traversal on Snyk-Learn, but I will come back to the resources and Snyk-Learn at the end of this session. I will hand it over to Micah for the second challenge. Over to you, Micah.
Great. Let's see. Am I back on the stage? There we are. There I am. Neat. All right. Well, thanks for that, Sonia. Hopefully others of you are working your way through the challenge. And I did see some comments along the way. First of all, Sonia's VS Code theme is awesome, and we're not going to tell you what it is. You'll have to figure it out on your own. Second, I know we are moving pretty fast today, and that's a constraint of time, but the idea here is not necessarily for you to get all the way through the challenge on your own, but really to look at those skills that are employed to participate in a CTF. So the next challenge we have is called Containers Are Ace. And let's take a look at this challenge. So containers are ace. Now, we want to gather clues right out of the gate and kind of analyze those clues. First of all, one thing that's worth noting here is this is worth 300 points. It's worth more points than any of the other challenges. So you might be able to draw the conclusion from that this is probably a harder challenge. Usually, the more points, the tougher the challenge. That kind of makes sense. It's not a straight line. It doesn't mean that it's 3 times as hard as File Explorer, but we at least know it's more of a challenge. We then get some other clues here. We know that it's Java-based. It's this thing called Tomcat and Snyk container. So these clues, we kind of want to file them all away and come back to them. Maybe I've never heard the word Tomcat before in the context of tech or CTF, but all of this is Googleable, right? And Google is your friend in working with CTFs. Now, you do want to be a little bit careful. You could probably do a search for Snyk Containers Are Ace solution and just get a write-up and get the full solution. That's probably not what you want if you're, looking to participate in this challenge. But you can look up things like what is Tomcat, or what is Java Tomcat, or what are containers, what are Snyk containers. So these are all things that you can look at. We also have this clue, and my eye is kind of drawn to ACE in all caps. Why is ACE in all caps? If you have an inkling about what that might be speaking to, drop it in chat. It's okay to share clues like that with each other. What do you think ACE might mean? And then it says containers are ace, but what about cats and coffee? Well, cats might relate to Tomcat here, and coffee, Java is also coffee aside from being a language. So there may be some clues there that are telling us the way to, get the exploit, the way to find the flag is going to be related somehow to this Java and Tomcat business. Now, we also have these 3 hints. I'm not going to reveal the hints just yet, but one thing to know about CTFs is that sometimes the hints cost you points. And if that's the case, it'll tell you. It'll say like view hint, And then in parentheses, it'll be like 30 points or something like that. And that gets deducted from the total points that you can win for the challenge. Sometimes it's worth it to lose a few points to get a leg up. Now, we're going to come back to the hints a little later, but we're going to leave them be for now. So finally, we have this link, which brings us to this application, and it's called containers are ace.ctf.sync, and it's bringing us to this /to-do list. Well, just being curious, I'm going to get rid of the /to-do list, and let's see what happens. So this is interesting. This is probably not intentional. This may be a mistake from the developer, but I'm at the front door of this thing called Apache Tomcat. It's giving me a version. Anytime you see a version for a particular piece of software, that's another clue that you can use. So I'm already getting a bunch of good clues here, and I can go to the documentation. I can start doing some Google searches, but that's kind of an interesting bit of information here. Now, I know this is a web app, and I want to poke around the web app a little bit. So I'm just gonna sign in, and I don't really want to use my own email, so I'm just going to use Sonia's email. And, I don't know, I'll just put in a super secret password here. And I'm going to click sign in. All right, well, that's no surprise there. That's invalid. How about registering? I'm going to be Sonia. And I'm going to put in a super secure password if I can type properly. And I'll click sign up. All right, well, this looks like a to-do list app. I want to be aware of rabbit holes, right? I'm not going to spend a ton of time on this app. I don't necessarily care about the finer points of the app. I just kind of wanted to poke around and see what I could do here. So some of the clues that we get right out of the gate are, we have this URL, we have this tagline, containers are ace, but what about cats and coffee? When I'm working with a website, and when I think there might be some way to exploit the website, I immediately think of Burp Suite, and we're going to look at that in a moment. But if you've never used Burp Suite before, it's a way to capture and replay interactions with websites, and you can alter the requests that are made and maybe exploit some vulnerability in that website. All right, let me just see. A couple of you wrote in the chat, ACE, arbitrary code execution, right? So that's a common term in security circles. And I'm curious, I didn't actually do this search before, but let's see what happens if I just do a search for ACE security. It's probably going to give me a bunch of companies. Yeah, ACE Security Technologies. I'm looking to see, or let's see, how about this? What does ACE mean in security? How about that? Oh, there we go. First hit, right? So the fact that it was capitalized that way kind of drew my eye to it, and this gives us a nice little clue. So I'm going to file that away. If you don't know what arbitrary code execution is, you can do some further Googling, right? But we have all these clues that we're building up. Now, as soon as I logged into this site, I see there's an about. And so I'm going to look at that about page. And this gives me a whole bunch of other information. So I know that this is running on this thing called struts2. Now, I'm pretending I don't know anything about Java or struts or containers. In real life, I do, but I'm pretending that I don't, to kind of show you that you don't really need to have a deep subject matter expertise to start finding out and to probing around for these clues. So struts 2.3, Spring 3.2, Hibernate 4.3. Let's pretend I don't know what any of those are. The very first thing, but having these very specific versions is super useful in the context of a CTF. So the next thing I'm going to search for here is, let's do struts 2.3 vulnerabilities. And you can see that I've been here before. And our very first hit here is Apache Struts version 2.3.10 security vulnerabilities. Well, that sounds promising, because I know that I want to exploit some sort of vulnerability or some sort of unintentional way to get this flag, right? That's ultimately my goal. Now, if you've never seen a page like this, we have these ratings over on the side, these CVSS scores, and you can see there's a bunch of high ones, right? And it's color coded to give you an inkling here. So red is much worse than yellow. And I see there's a bunch of 9.8s. Those are super high. Anything 9 or above is super high. But interestingly enough, there's only one that's smack dab at a 10, and that really catches my eye. Again, we want to be able to move quickly in the context of a CTF so that we can, get a flag and move on to the next one. So, all of these may be interesting. All of them may be relevant. I'm going to start at the one that is a 10. And I have this now very specific CVE, and it gives me some more information here that I know is very related to what I'm looking at. So Jakarta is a Java technology. If I didn't know that, I could go and look it up. But I know I'm dealing with struts. It has something to do with the content length. Like, I'm kind of gathering all these clues as I read this very quickly. And content type, by the way, is called out here as well. If you're not very familiar with the HTTP protocol, these are all related to the HTTP protocol, and they're very Googleable. It's very, very easy to find out why, content type is used, where content length is used. But since I have a very specific CVE, I'm now going to Google this. No, I don't want that. I want just the CVE. And I'm going to Google CVE POC. Everybody knows what POC stands for? Drop it in the chat if you do. Yeah, close. NahamSec, nice, love it. Yeah, point of contact. No, proof of concept, right? So I want to move fast here. I'm not looking to get a deep knowledge of Apache struts. I'm looking for exploits specifically related to this CVE that I've found. All right, now so far, no knowledge of struts required, no knowledge of Tomcat, no knowledge of containers, right? We're just following the breadcrumbs and doing some creative Googling. So now the first hit I get is to this GitHub repo, and there's a bunch of interesting things in here. I'm going to look at this CVE 2017-5638.py, right? There's a Python example of exploiting this Java vulnerability. But one of the things that I see here that catches my eye is this payload, right? This is very nicely named payload. So this is the thing that's going to exploit this vulnerability with struts. And it looks like a whole bunch of garbage to me. I have no idea what this encoding is, but what I do know is that this is the thing that's going to exploit this CVE. Now, I could kind of, copy and paste this and pull it out into a single string. If you notice down here, when it goes and makes the request, it's using this payload as the content type. And if you remember from before, we saw here that content type was related to this CVE. Now, I'll tell you as an aside, this is OGNL. It's a language that's very specific to struts. I forget what it stands for, honestly. But it was never intended to be jammed into a content type. Content types are things like application JSON, text HTML. So we're kind of misusing the content type here, but this, triggers this exploit within struts. So I know that I'm going to want to send this whole long, ugly, gnarly string in a content type header. And one thing that I could do is I could go and copy this whole thing and concatenate it together and kind of craft my own string here to mess around with our to-do list system. But I noticed that in this repo, there's a one-liner, a one-line POC. Well, that is super convenient and handy for me as a CTF participant, because now I can get straight to it. What I'm going to do here is I'm going to copy everything in the content type. I have no idea what this is going to do just yet, but I know I want it, and I know it's going to help me with this exploit. All right, with all that under our belt, I'm now going to turn back to my application, but I want to do it in the context of Burp Suite. And the reason is that Burp Suite is going to allow me to interact with this site and then replay some requests and allow me to manipulate that content type header. So if you've never seen Burp Suite before, here it is. And I know it's kind of small. I'll zoom in. But where we're going to start is by opening the browser. And this browser that we're opening is bound to Burp Suite. So any URLs that I put in this browser are going to be captured in Burp Suite. All the requests will be captured. So I'm going to grab this URL. And I'm just going to get rid of the end of it. I'm going to go back to the front door. And if I look over here at the target tab, I can see all of these requests that are being made. And I'm going to go ahead and sign in. And I'm just going to put in garbage because I don't really care about signing in at this point. But I know that when I click sign in, it's going to result in a post request to the website. And now what I want to do is replay that post and alter it in a handy way. So over here, we can see that post. Even though it failed, I don't really care about that because what I can do inside of Burp Suite is I can send that to the repeater. And when I go to the repeater tab, this is the request that was made. And we know it's a bogus request, but the thing I can do here is that now I can alter things. So I can alter this content type header, right? This is a valid header, application X www form URL encoded. That's very standard for submitting forms. But what I want to do is I want to paste in that long, ugly, gnarly string that I copied from the POC. Remember, I don't have a deep understanding of this string. Doesn't matter. I'm just going to see what happens when I send this through, and let's see what the response is. Well, look over here. This is very interesting. This looks to me like kind of an unformatted directory listing, right? Just from clues, I have a license file, I have a logs file, I have a web apps, that's probably a folder. So now that this is kind of a foot in the door, and that's a lot of what hacking is. You get a foot in the door, and then you craft a more sophisticated payload to be able to get further. Now that I have some sense that I have a foot in the door, now I want to finally look at this and see if I can figure out what's going on here. And where my eye is drawn to is this command equals dir, right? And this is a common Windows command. So happens it works on Linux now. It didn't always. But over here, I can see that that command, whatever's in it, is being passed to a bash shell and being run. So this is pretty cool. It looks like this exploit lets me do what? Arbitrary code execution. So let's put in some different arbitrary code here. I'm going to say ls, let me just make sure I didn't mess anything up here, ls-la. Now it's wrapping in a weird way. It's because it's this long, giant string. I don't really care about that. I'm going to go ahead and hit send again. All right. And now this is a proper directory listing, right? So now I've kind of proven, and my hunch was correct, like web apps is a folder I can see. And now I've gotten to the point where I can run arbitrary commands. And I just want to highlight no knowledge of Java, no knowledge of struts. It happens to be running in a Docker container. Don't care about that. I'm making really good progress here because I've been able now to do something that is not intended, right? This system did not intend for me to start, arbitrarily running commands on it, but now I've done this exploit. So drop in chat, where would I go next, do you think? What's the next command I want to run to be able to find the flag? I'm guessing that somewhere there's a flag. That's the whole point of this. But what's a quick way for me to get at it? Anybody have any ideas you want to drop in chat? Be shy. I'm looking off to the chat window if you're wondering why I'm looking off to the side here, different screen. VI, very good. LS, grep, I like grep. Very good. Find, yeah. Find is the winner for me. All of these are really good ideas and they would probably work, but let's take a look at find, right? So in case you're not familiar with this command, I'm finding dot, that's the current folder. I'm looking for files, right? I don't care about directories. And I'm looking for any file that has the name flag in it. Now, this could be a red herring. It's possible that there's some file here that contains the flag, but isn't named flag. But I'm trying to go for the lowest hanging fruit so that I can move as fast as I can. And when I execute this command, well, look at that. Under Web Apps To-Do List, there's a file called flag. What's another command I can use now to look at this file, to look at the contents of this file? Anybody care to drop it in? Cat. Yeah, Fran's got it there, cat. Right now, I never tried this. I wonder if I can go there directly. Let's just see if it'll serve me the file. Nope, it won't serve me the file. So that's okay though, because I have my nice little exploit here and Fran's given me the idea to go and use cat. So I'm just going to paste that path in with the cat command. I'm going to send this request one more time. And now look at that. It's not exactly nicely formatted, but this is, let's see if I make this bigger, it's all one line. I now have the flag. And if I come back here and go to my CTF 101, I can drop that flag value in, and there's my 300 points. Sweet. All right, now just to wrap up here, let's just say that you didn't go along that particular path or you got stuck in some way. Well, that's what these hints are for. And in this case, the hints don't cost us any points. So here's the first hint. It's saying go grab the Sneak CLI. Okay. And again, I want to point out Sneak was not or is not a requirement for this, but it may be very helpful. The second hint is to run this specific command. That's interesting. Well, maybe I have no idea what this command is doing, but sure, I'll go and run that command. I'm going to run it right here. Now, it takes a moment because it's going to fetch a remote image, a remote Docker image, and it's going to interrogate that image. So rather than waiting for that to finish, this is the output that it's going to produce. And you all gave me the hint earlier of arbitrary code execution, right? So I can see that in the output, there's a whole bunch of these arbitrary code execution. I'm going to grab one of these URLs here. Not sure if I did it right, but let's just see. Let's see if I did it right. Right, and here's our level 10 CVSS score. And then from here, I could follow along, and kind of do the same thing that we did. Well, tell me more about this 2017 5638. This was kind of another way to get to it. And that's very useful when you're participating in CTFs. Don't be shy. Don't hesitate to use hints, especially if they don't cost you points and especially if you're stuck. They're there for a reason. And then if they do cost you points, you'll make that decision on, whether or not you want to take that hit. If you want to get, if you're going to get 250 out of 300 points and you're going to get there quicker because you viewed the hint, it might be worth it. All right. So with that, I'm going to stop. I'm going to stop screen sharing and I'm going to turn it back over to Sonia.
Hey, thanks, Micah. So hopefully you managed to solve both challenges. Hopefully. If not, I'll give you the resources so we can do it after this. But let's see Go and CTF, a couple of learnings and resources to end the session. So the first one is it's okay to learn from mistakes. There are a few things that you need to keep in mind. So the first one is to embrace curiosity and don't be afraid to ask the what-if questions and experiment with unconventional approaches. So You've seen with my demo and Micah's demo, we've tried different tools, and we tried with Google. We Googled some of the results, and we tried different paths. Also, make sure to have some sort of ethical reflection. If you did some mistakes or you didn't really understand, that's fine. You can come back and try it on your own, even if you didn't manage to solve both challenges. The most important thing is to be persistent and resilient. This is good skills to have when you're doing CTF challenges. You need to bounce back from failures. You can adapt your strategies and approach the challenge with another point of view, with different tools, also different methodologies that you might be learning from CTF. The important thing also is to have collaborative learning as well. Because we're all here in the chat sharing some ideas, some tools, which is great, and celebrates the small wins if you did manage to solve at least one of the challenges. So maybe some of you are wondering how I can transfer the skills from the CTF that I did to potentially security jobs. So there are a few ways to do so. The first one is around technical skills, because when you're doing CTF, you're using a plethora of tools and different skills. So these are potentially good way to directly apply them to roles in cybersecurity, penetration testing, and ethical hacking. The other one is obviously analytical skills, because you are actually trying to do some problem solvings, to analyze data, to discern different patterns and vulnerabilities in the challenge. So they're really good also to have for security jobs. And this goes also to strategic thinking, how you could tackle CTF challenges. And this is also good skills to have to bring in on the table. Obviously, collaboration and teamwork, because you're going to work in a team. So this is also a good thing to have. And the big one, obviously, problem solving. So it's a good thing to get the flag, but also to have that mindset to try to solve all of these CTF challenges. Also, try to engage with the CTF community. There are different ways to do so. You can use the chat group. So some of the dedicated, for example, Discord servers, the Slack channels, and different forums where you can potentially discuss with your peers and those who are also doing some CTF challenges. Obviously, social media communities as well. You can follow up on Twitter and other platforms. People are solving CTF or doing ethical hacking and pen testing. And also CTF blogs on the website, because you might actually have solved the CTF in a way. It's always interesting to read others' blogs just to see how they've actually solved the challenge, which tools they've been using, what was the methodology. You can always learn something new from other blogs and websites. So a couple of resources we'd like to share before closing this session. The first one is the dedicated CTF 101 hub that we have. So obviously we only have 1 hour session today, but if you want to dive on this topic, we do have a dedicated hub where you have everything on how to get started with CTF, the different type of CTF challenges, if you're interested, a few of the platform and practices, the strategies and techniques, the tools. So you have all of that in this hub. We also have the Sneak blog, where we do spend some time writing blog posts on different security vulnerabilities and topics. So this is also a good way to upskill your security skills and knowledge. We do have write-ups and walkthroughs. So if you didn't manage to actually solve those challenges, the good news, it's actually up on the platform. So if you go on the solutions, only if you tried a little bit before, because this is going to give it away, but you do have the solution for all of the 5 challenges. So the first 2 with on our videos, and the 2 others are the blog posts where you will see the solution. If you want to also upskill your security knowledge, you can have a look at the SneakLearn platform, which is our free online security platform. We do have a plethora of security lessons on different topics. Here, because I mentioned directory traversal in my CTF challenge, here you can see this is a 1-pager. Depending on the ecosystem, you can select it. And actually, everything is sandboxed, so you can actually try the payload if you copy-paste the payload, and you can try different payload on it. If you don't know where to start, we do have a couple of learning paths. You can start with potentially the OWASP Top 10. It's always a good start. And once you're done, you can download a certificate and share it on your social. And the good news also is we're actually starting a learning path around AI, if that's a thing that you want to learn. Just going to remove this here. So we do have, we have a new lesson. I didn't realize we had 4 yesterday. And we're starting a new learning path on the OWASP Top 10 for LM. So if this is your thing, you can have a look at it. If you're more a visual type of person, we do have our dedicated Sneak YouTube channel, and also a huge shout out to Brian Clark, who's doing a lot of great videos on it, so you can have a look at it. And obviously, I think we've shared our Discord if you want to get involved in our DevSecCon Discord. This is a vendor-neutral Discord where we talk everything related around DevSecOps. Also, if you want to learn more about CTF and other topics, you can go on this Discord channel. And that was all for the links. I wanted to thank you all for actually attending this the CTF. I do hope that you learned a few things around the this session with the 2 challenges. Maybe you managed to solve the 2 challenges, maybe one, maybe none. But yeah, you on the platform, you do have the solutions. You can do it on your free time. Thank you. I'll let Micah say the final words.
Thanks, everybody.
Yeah, thank you guys for hosting this year. And I think this is one of our most favorite workshops that we bring every year. So having you guys 2 years in a row means a lot to me and the team behind the conference. Thank you guys. And yeah, for everybody wanting to learn more, make sure you go to sneak.io. And for everyone asking, this will eventually be online at some point. So if it was a little too fast paced for you, you want to revisit it later or do some of the challenges later, you will be able to do it on your own time eventually. So thank you guys. We're going to take a quick little break, and we're going to come back in about 10 minutes with our WordPress workshop, which will be hosted by our friends at PatchStack, which involves doing a little bit of code review, finding vulnerabilities on WordPress themes and plugins. That one, unfortunately, is pre-recorded because there is a lot of problems with time zones, and also there's problems with making sure that all the demos work. So we have to do that one pre-recorded. I think they'll be around in the chat to answer any questions that could happen. If anything comes up, we'll make sure to put you guys in touch with everybody that's on the team. So we're going to take a break. In 10 minutes, we'll be back with the WordPress workshop. See you guys in just a bit. All right. How's it going, everybody? We have a few more minutes before we can announce our next speaker and workshops. But before we do that, I want to kind of get to hang out with everybody. Let us know when you're watching this from, or what country you're from, or maybe what state you're in and you're watching this. I would love to kind of hear from everybody and kind of get an audience check of everyone that's watching this. Where are you watching this from? Let us know. When I look at the chat, I see Justin is in here too. Shout out to Justin. He will be hosting the NahamCon tomorrow. So if you're watching tomorrow, he will be our host. Let's see. Swiss. Love Switzerland. Love it. ATX. IR. Morocco. India. Michigan. From Puerto Rico. Nice. France. Poland. Nice. Norway. VA represent. Let's go. US West Coast. Shout out to Stay Blazing. What were you, 43 months strong on Twitch with us? Shout outs to you. I appreciate it so much. Bangladesh, India. Let's see. What else do I see? I see India, Nepal, France, New Jersey, Brazil, Hungary. Hey, OSINT made easy. Now I have now all I need is your last 4 digit of your social security code, and we will need also for you to give us your mother's maiden name and your pet's name and your date of birth. And I think that's all we need. Throw them in the chat. Don't worry, it's going somewhere safe. I see people from Finland, Portugal, Guatemala, Canada, Brazil, Chile, Jordan, UK. LOL is not a country, Justin. All right. Enough about that. Thank you guys for being here. I really appreciate it. This next talk is going to be pre-recorded. Again, this is because we want to make sure that everything that we have here goes as smoothly as possible. So with that said, it is pre-recorded, but the host for the next workshop, both of them will be in the chat. They'll be answering some questions. Again, if something is way too fast-paced, maybe you missed something, you want to review it later, maybe you want to just watch the workshops later, the entire thing as it is being shown right now will be available on YouTube right away. So you can go ahead and watch it on your own term, but we're not going to more than likely take these different workshops and spice them up, if that makes sense. So they won't be available on their own immediately. Maybe later we'll just publish some of them on their own. All right. With that said, let's welcome our friends from PatchStack with Acing WordPress hacking through code review.
Hello guys, today we are from PatchStack. We are gonna do a workshop about Acing WordPress hacking with code review. In this sections, we are gonna discuss everything WordPress related for a code review. So first of all, let us introduce ourselves. My name is Raffi Muhammad. I'm a security researcher at PatchStack.
And I'm Ananda Taka. Similar to Rafi, I'm also a security researcher at PatchStack.
Yeah, so we are PatchStack. We have a PatchStack Alliance, which is an active community of ethical hackers that will earn rewards for reporting security vulnerabilities in the WordPress ecosystem. We also have MVDP program, or Managed Vulnerability Disclosure Program, which help developers to streamline their vulnerability reporting better. And we handle all of the steps. We also an official CVE numbering authority, or a CNA. So we are actually the biggest CNA in 2023. We are assigning most of the CVE in 2023. So in this workshop, we are going to discuss about 2 things mainly. The first one is about WordPress hacking, getting started. This section we will discuss how to get started and in the WordPress hacking experience. And then we also will have a deep dive into the WordPress vulnerabilities and how to exploit them. All of these workshop materials actually will be hosted in this domain, academy.patchstack.com. So you guys can just go to the website and try it out. Okay, now we just gonna jump to the main materials. So first, Ananda will be delivering the first phase of the materials.
We'll be starting off the workshop with introduction to WordPress itself. WordPress is the most powerful and popular content management system, and it is completely open source, meaning that the source code of WordPress is available for everyone to view and play around with, and it has been contributed by hundreds of contributors, developers worldwide. It is built on PHP and uses a MySQL or MariaDB database. Almost 43% of all the website on the internet is powered by WordPress. The market share is really used for WordPress, and it was created in 2003. WordPress not only consists of the core itself, but it consists of the plugins and the themes as well. So WordPress plugins are basically the additional piece of software that you can install in your WordPress site to gain some additional features or functionalities as well. Similarly, WordPress themes are basically the designs that you want to use on your WordPress site. There are more than 59,000 WordPress plugins that are available, which are also open source, completely free, and source code available for viewing as well. Similarly, there are more than 12,000 WordPress themes available for users to install completely for free. So WordPress plugins and themes are what makes WordPress really interesting, and most of the security vulnerabilities we'll be discussing will be revolving around the plugins and the themes. Introduction to WordPress hacking. One of the main reasons for choosing WordPress as a platform to secure is because of how big the WordPress ecosystem is, how big the user base of WordPress is. The other reason is how much neglected the security for WordPress plugins and themes is for WordPress compared to its core. The core itself has been reviewed over a really long period of time by thousands of developers and researchers. As a result, it is really secure. Compared to that, the plugins and themes are almost completely ignored, leading it to be full of vulnerabilities that can be exploited. If one plugin with 10,000 installation gets hacked, it's 10,000 sites that can be breached into. Hence, choosing WordPress is a platform to secure will make sure that those sites are not hacked because of the WordPress plugins or themes. One of the main objectives of PatchStack is to create an academy that enhances a reader's perspective and understanding of WordPress security in a white box format. So the reason for selecting white box format is so that people can get deeper understanding of how vulnerabilities can emerge and be fixed in the code level. So moving on, if we look at some vulnerabilities from the State of WordPress Security white paper that was published by PatchStack, this white paper basically includes all the ins and outs of WordPress security in 2023. And we can see that in 2023, almost 6,000 vulnerabilities were added to the PatchStack vulnerability database. Out of that, 96.77% of the vulnerabilities were in plugins. So this stats highlights the primary target being plugins and how vulnerable the plugins are in the current scenario. So with plugin being the main target, we need to look at the statistics on what were the required privileges for each of those vulnerabilities. So almost 59% of vulnerabilities required no privilege, meaning that a lot of the vulnerabilities were pretty serious, because requiring administrator privilege contributor is something really rare in context of the real world scenario. However, unauthenticated privilege is something that can be exploited really easily. So these are some of the statistics that are presented to us by PatchStack for the security of WordPress in 2023. And given this, we can conclude that WordPress hacking is really relevant to this date as well, and it is mostly driven by the vulnerabilities in plugins and themes. So it is crucial to protect and secure those open source plugins and themes. There are various ways you can follow through to set up WordPress for hacking. One of them being Apache MySQL method, the traditional XAMPP, LAMP, or WAMP stack method you can follow through to set up on your instance. But for this workshop, we'll be going through the Docker setup because it supports cross-platform and it's really easy to set it up. Given that we have this repository with just 4 steps, we'll be able to set everything up so that we can set breakpoints in the Docker image as well. So yeah, as I mentioned, debugging, we need to be able to debug the WordPress site because we need to go through the code, we need to step through, set breakpoints so that we can properly analyze all the functions, all the code that is running in a plugin or the code itself. So for that, we use the Xdebug. We can do that manually. We can set it up manually as well with Xdebug, but this Docker image comes up pre-installed with everything that is required for us. So yeah, the WP Xdebug Docker, which we have on our patchstack GitHub repository, it comes up with WordPress Docker instance, Xdebug configured, and the file upload limit includes. So following through this step, we just need to git clone cd into that directory and just docker compose op -d and everything will be good to go. So I've already done the git clone part. So we will cd to wp xdebug docker and just running this command would give us the Docker container up and running. Please note that if you are on macOS, you need to follow these steps because it might install the AMD version if you just follow through this step. So we need to create an image of the ARM version and use that image. I've already done this part. So if you are on macOS, please follow this. If not, just these 4 steps should be good to go. So we have WP Xdebug Docker up and running. If we navigate to localhost port 8000, yeah, we can see the welcome page, and please make sure that you're not setting easy password if you're in production. And yeah, we can see the login page. So to be able to debug this, we first need to get ourselves on VS Code and we need to install a couple of extensions. So the extensions that we need are dev container and PHP debug for the VS Code. So dev containers, this is one of the plugins, VS Code plugins that we'll need, and PHP debug. I have already installed both of these. You can just install them by going to the extension section and just install it. So now that we've done this part, what we need to do is open up a fresh instance of VS Code and click on connect to, attach to running container, and select the WP Xdebug Docker WP1. So what this will do is connect our our VS Code to the WordPress container. So here we can see it is connected and we can navigate through the code, all the code that is out here. So what we need to do is click on run and debug, and we'll need to create a launch.json file. And yeah, it gives us the default launch.json file, but we'll be using this so that it is just easier for us to copy and paste. So we are listening on port 9000 in our Docker image. So we need to attach to port 9000. And yeah, so now that we've done this, we can just click on run and debug and listen for Xdebug. So it is already running. Yeah, yes. Okay, so I guess, yeah, it's already running. So if we try to set a breakpoint in wp-login.php, and if we reload this, yeah, we can see that the breakpoint is getting hit, and we can navigate through all the code, set breakpoints, step through the code using this in just 4 steps if you're not on Mac, and a bit more steps if you are on Mac. So now that we've installed the plugin, we can just log in and see if everything is working correctly. So yeah, we can see the admin dashboard for the WordPress, and we can add new plugin as well. There is a limit set by WordPress, a default limit of certain MBs, but we've updated it to uploading a higher file size for the plugin, so it should be good to go. So now that we've done the WordPress setup, we can move forward with the steps. In this section, we'll be going through all the tips and tricks that we can utilize for WordPress hacking. So we'll be discussing various tools that will make our life easier for WordPress hacking. So the first things first, we have a tool called SVN, plugin subversions, which allows us to browse through all the source code for all the open source plugins. And we have a tool called WordPress track, which allows us to track the different versions of the plugin, track the different development stages of the plugin. And we have a tool that allows us to mask hunt the code patterns as well. So firstly, we'll navigate through SVN and understand how it works. So this contains the list of all the open source plugins in the WordPress repository, and browsing to any of these, we can basically view the source code for them. So if we go to /Elementor, we can see that we can view everything for the Elementor. So in the asset section, we'll have all the PNG, GIF files and all. And in the tags, we'll have different release versions. So the current release is 3.9.2, whereas we can view the release version of 0.1.0 as well. And in the trunk basically contains the latest version, latest code changes in the plugin. So we can basically browse through these as well. So if we go to /app and app.php, we can view the source code. So similar to this way, we can view the source code of the latest version or the older version of any open source WordPress plugins. And it's the same for theme as well. It can be viewed through themes.svn.wordpress.org. So everything else is basically the same. That is it for the WordPress SVN. All the categories are described in the blog post. And moving on to WordPress track. So this is a really important feature that we'll be using, and we'll be using it all the time during the WordPress hacking session, because it contains the changes that are introduced in the WordPress plugins. So it looks similar to SVN, but in a better UI way. So yeah, it has all the same options: assets, branches, tags, and trunks, and the work is also the same as it is in the SVN. So it's loading tags right now, and we do have so it's all the same. We do have an additional thing that we need to look up, and that is rev. This is a revision history. So through this, we'll be able to know the revision history of the plugin, when was the code changed and what changes were made in the code. So in order to view the last change that was pushed to the plugin, we can basically click here and navigate to this URL, and we can see all the diffs. So if we look for some PHP files, so yeah, and click on view diffs, we can basically see the changes that was made during the latest version of the code change. So similar to that way, we can basically navigate through all the changes of the plugin. So we can see the changes in 3.21.4 as well as 3.21.3. So this changes is about the release version 3.21.4, and if we navigate to this page, we can see all the changes in 3.21.3. So if we want to see changes on different versions, so for an example, we want to see all the changes that were made in between 3.21.2 and 3.21.4. So we can just do this and click on view changes, and here we go. These are all the changes that were made in those two different versions. So if we navigate to any of the files, we can see the changes. So for this one, there is no change except the date. So there should be some changes in the PHP file. Yeah, so it's the change was the same in the two version changes. So yeah, this is a way we can track all the changes, and this is going to come really handy later down when we'll be doing CV reversing, because knowing the difference in the version, knowing all the code changes in certain version will help us debug and demystify the security vulnerability that was present in that version, which we'll be discussing later on in the WordPress CV reversing section. So this is it for WordPress track, and now we have a tool called WP directory, which allows us to mask hunt the code patterns. So for an example, you found a certain code patterns that leads to security vulnerabilities across a lot of plugins. Maybe a similar design, a similar way of implementing the code that leads to a certain bug. So if we want to find the same bug across multiple plugins, we have a tool called WP directory, which allows us to do regex searches. And based on those regex searches, it scans across the WordPress org/plugins directory and give us the result, give us all the matching results. So for an example, if we want to look for the unserialized function that is being used across the plugin, it leads to a PHP object injection. So if we want to look for this, we can basically search for unserialized keyword, and there will be lots of results, because obviously it is used in a lot of places, but if it is taking in user input, then only we can consider it vulnerable. But yeah, so we do have an example of unserialized with $_get, which basically means it is directly taking in the user input and putting it inside the unserialized function. So if we, okay, there is just too many results for this, so I think we can just skip it. So if we look for this pattern and search it, we might get a little bit smaller result. So yeah, there is only 8 matches till now. Okay, so only 10 matches, and we can see that the plugin name and the file name and the code as well is given to us by the WP directory tool. So there's a variable that is storing the unserialized user input value. So this basically leads to PHP object injection, which we can exploit. So in this example, this plugin is most probably closed. Yeah, so this is already closed for most likely due to the security vulnerability. So yeah, this is an example of how you can search through the whole WordPress code base for a certain vulnerability, in case you come across some interesting patterns. So yeah, that is it for mass hunting coding patterns and this section. Now that we've completed the getting started section, we'll be discussing the vulnerabilities part now, where we'll go through the code of what the vulnerable plugin or theme might look like for a certain vulnerability class, with some demos as well. We will be starting off the vulnerability section with broken access control. So this is one of the most common security vulnerabilities in WordPress plugins and themes, due to how easy it is to miss adding permission checks in the actions and functions. So there are various ways broken access control can exist in a WordPress site. So there are different hooks that are basically being attached with functions are being attached with hooks, which gets executed upon a specific scenario. So when the function is being executed and data retrieve or modification or deletion is being done, if there is no proper permission check, then we can find broken access control vulnerabilities. So going through this, first we have the init hook. So in order to learn more about the hooks, you can navigate to WordPress internals and hooks section. So the init hook is basically the hook that runs after the WordPress environment is loaded, but before the current request is processed. So every time you open the WordPress site, it will be loaded, and any actions that is being attached with the init hook gets executed upon WordPress site load. So in this example of the vulnerable code, we can see that an action is being with init hook to check if update, and it is basically checking whether the get parameter update exists, and if it does, the option is being called to modify the value of user data. So in this case, we can see that there is no privilege check, and since the function is being attached with init hook, we can just load the WordPress site with the get parameter update, and this value will be changed. And similarly, admin init is absolutely same, except that we need to call the WP admin as X page. So everything is the same, but the only difference is that we need to call the WP admin page. So while the admin page is being loaded, it's called, and it's only checking for the push parameter delete, and if it exists, it basically deletes this option. So we do have an example here as well. Similarly, the WP-as-X action hook, this is one of the most commonly used hooks for WordPress, and this is the most, the place where most of the broken access control vulnerabilities can be found. So this case is a little bit different than the admin init and init hook, but yeah, the logic is the same. The hook is it always starts with WP-as-X, and the action is being attached with this function, which is basically checking whether the post parameter update exists or not, and if it does, it is basically taking the ID value and updating the data. In this case as well, there is no privilege check being done, and so all the WP-as-X action can be called by a logged-in user. So by default, an unauthenticated user cannot call a WP-as-X page. The minimum role required is subscriber, and so since there is no privilege check being done, a subscriber role can call this action by something like this. So this is the request which you need to send in order to trigger this hook. So we can see that. So one thing to note is that the WP_as-X underscore part is trimmed in the action place. We only enter the value after the WP_as-X underscore. So in this case, it would be update post data, and sending request with the action parameter of the update request value would trigger this hook and call this function, leading to broken access control. So we will be looking at the example of WP-as-X no priv action, which is absolutely the same, except that unauthenticated users can also call this one. So the only difference between WP-as-X action and WP-as-X no priv is that this can be called by unauthenticated no privileged user. So we'll be doing the demo of this one. So we do have WP-as-X underscore no priv. So this is the part that is omitted when sending the request. In the action request parameter, please note that the post request is being sent to wp-admin/admin.ajax.php. Sending this request will trigger this function. This function will check whether the post parameter toggle is equal to 1. So if it is, it will update the option accordingly, else the value of custom toggle will be 0. So if we send this request, we can see that there is no cookie parameter. This is a completely unauthenticated request. So if we send this request in the VS Code, we can see that this is being called and the function is triggered. So it is checking whether the post parameter exists, and yeah, it does, and the value is 1 as well. So the conditional is true, leading to update option, and the option being the value of custom toggle being changed to 1. So last but not least, there is one more function that can lead to broken access control, and that is register REST route. So register REST route, basically what it does is that it creates a REST API endpoint that you can send through /w position / the route that is being set, and the method can be defined. It can be either post, get, anything you want, and the callback is the function that is being triggered. Similar to this one, if we call this hook, this function will be triggered. Similar to that, the register REST route would call this function, and the permission callback is something we need to check to be able to find broken access control vulnerability. So if the permission callback is returned true, it means that any unauthenticated user would be able to request to that API endpoint and basically execute this function. So if there is any state changing or something sensitive API endpoint that is being set with permission callback set to return true, it would lead to indicated access or modification of the data. So in this case, we can see that the route is being set to my plugin /p1/delete/author, and callback is set to delete author username, and the delete author username basically takes the parameter user ID and deletes the user. So the permission for this one is return true, meaning that there is no privilege check, and we can basically execute the user deletion by this simple call request. Cross-site request forgery, CSRF. So CSRF is basically the same as broken access control. Anything that is vulnerable to broken access control will lead to CSRF in WordPress setup, except the case that the nonce is being leaked. But aside that, almost all of the cases where there is a broken access control vulnerability will also most probably have a CSRF. So all the in this section, the hooks are all the same. We do have init hook, admin init, WP-exec, and WP-exec no priv as well. That's not included here because obviously an unauthenticated user can just execute it. Same to the init hook and admin init hook. So an attacker won't really need to make a CSRF POC and send it to the administrator to click, because these are something that an unauthenticated user will be able to do it, except that there is some privilege check being done. So if there is a certain accent being hooked and there is privilege check but no non-token checking, then it can lead to CSRF. So for this one, we cannot execute this as an unauthenticated user because there is a check being done. So in this case, we'll need to create a HTML page that will auto submit the form and lead to a CSRF. So similar to this one, there is permission check being done, but there is no non-token check. So this will also lead to CSRF. So the most common case again is the WP-exec hook, and so we previously discussed that, and subscriber user is minimum privilege that is required to execute the WP action hook. So if we do not have the account for a certain WordPress site, let's say, then an attacker will need to create a HTML page. So for this one, we'll be doing the demo. So we do have the HTML page ready, which is basically sending the post request with update post data and all the other parameters. And we can see that there is this action is calling this function, and the function has the contents. We do have the breakpoint set. So let's try sending this request in the browser where an administrator is logged in. So we can see that this function has been triggered, and we can basically send this request. So okay, so there's a typo on this one on the code, so we'll need to do it once again. So sending this request once again, we can see that the post parameter has been checked, and we can basically call this function, and update post meta will be called with the change being done. So that's it for the demo of CSRF. Remote code execution. This is one of the most interesting vulnerability classes and the most critical one. It can basically lead to whole server compromise as well. So there are various ways one can achieve remote code execution in an application, but we'll be majorly focusing on the use of dangerous function in this case. So arbitrary file upload is one of the other cases that can lead to RC, but yeah, we'll be sticking towards these functions. So there are several functions that can lead to RC if the arbitrary user input can be provided into these functions. For an example, system exec, cell exec, call user func. These are some functions that should be used very cautiously, and the user input should not be provided without any sort of sanitizations, as it might lead to remote code execution. So if we take a look at one of the examples, so there is a concept called dynamic function call, where we can basically ask the user to provide the function as well as the argument. So in this case, action and input function and the argument correspondingly, and this can lead to something like system and the arbitrary command that we want to execute, leading to RC. So we do have this example case right here, which we also have here. So basically, a shortcode is created which calls image render callback. It's basically asking for three user input fields, attributes, sanitize, which has default value to esc_ttr, and esrc and ts text. So in the logic, there is a chosen callback is assigned to esc_ttr, skip attribute, and there is an array which consists of these functions. So if the attribute user input attribute sanitize does not have the value inside these, so if the sanitize is not one of these values, it will just be the one that user has provided. So after that, it checks whether the chosen callback is empty or not, and whether it is callable or not. And if it is not empty and callable, it is basically passed on to the call user func, which again taking attributes text, which is also user input, is the input, and using the dangerous function that where the application was not meant to use. So we just set a breakpoint right here, and we're logged in as a contributor user. To be able to execute the shortcodes, we need minimum of contributor privilege. So we can just create a new post. I've already created a post with the attributes, so we can just keep this for now. So yeah, file read, and this is what we're calling image render shortcode, and we have these attributes: assertion, sanitize, which is set to system, and the text is set to cat/etc/password. So if we can successfully execute this, we should be able to view the etc password of the server. So we do get an breakpoint hit right here. So if we forward this, we can see that the chosen callback is system, and the attribute text is set to cat/etc/password. So it is basically returning, and we can see that the etc password is disclosed. So if we enter some reverse code right here, reverse code execution would not be a big deal in this case. PHP object injection, insecure deserialization, in other words. So we'll be discussing about the PHP object injection in this section, and it is a simple vulnerability, but complex at the same time. Simple in the sense that it is really easy to find it. We just need to look for unserialized and maybe unserialized functions across the code base and check whether user input is being passed into those functions without any sanitization of some sort. So, but the complex part about this is that it cannot be exploited without a gadget chain. So gadget chain is a class that basically gets called upon execution, upon serialization or the deserialization of the data. So an example of gadget chain is this class of object injection, which will call the destruct function automatically when user data like this is deserialized. So you can find a lot of gadget chain in WordPress core itself as well. To this link, as of the latest version of WordPress, there is no known gadget chain. So in order to exploit the PHP object injection, some sort of gadget chain needs to be there in some plugins or some other softwares that are being embedded. So we do have an example case right here. We will not be doing a demo in this case due to how limited time we have for the workshop. And so this is basically the function which is taking in the user input and passing it to maybe unserialized function. So the data is being taken from the user, and the data is being passed down into a hash and value, and basically being unserialized. So to exploit this call request would be now with the basic 64 encoded value of the PHP object injection payload. From here on, I'd like to invite Rafi to continue with all the other vulnerability classes.
Okay, so now we are going to discuss about arbitrary file deletion in WordPress. So this section will cover cases of possible arbitrary file deletions. This includes improper file or directory deletions handling inside of the plugin or theme, which can be used to delete arbitrary local files and directories inside of the WP server. We have several functions that could be used to identify a possible arbitrary file deletions vulnerability. First, we have PHP-related functions such as unlink to delete a file, or rmdir to delete a directory. And then we have a WordPress-related function such as wp delete file, p delete file from directory, and then we have wp file system direct class, which have delete and rmdir function to delete a file or delete a directory. We move on to the example cases. Below is an example of vulnerable code. So here we just create a REST init setup function, which will register a custom REST API endpoint to the endpoint my plugin /v1/delete media. Then we set the callback function to the delete media upload function, and then we just use the permission callback to return true, just for this example. So the function basically just will receive our post body parameter as a JSON, then put it on the args variable, and then it will delete the file using the WP delete file based on the args media file variable that we supplied previously. To exploit this, any unauthenticated user just need to perform a post request to the designated custom REST endpoint, specifying the needed parameter to trigger the WP delete file function. So before we test this example payload, we will try to intercept or set a breakpoint to the function. Then we will try to hit this custom REST API endpoint. So yeah, in this example, we're just gonna set the WordPress base directory to my current WordPress base directory, which is located in the srv www/wordpress, and then we are gonna test to delete the license.txt file. Yeah, we're gonna change the URL. Yeah, and then we hit a breakpoint, so it just will accept our post body inside of the args variable, which is this, and then it will execute the WP delete file. Yeah, we can see that the status is set to true, which indicate that the file deletion process is successful. And then we can confirm it by checking the file inside of this directory, and yeah, the file is deleted, so the POC is successful. We move on to the arbitrary file read section. In this section, we will cover cases of possible arbitrary file read on WordPress. This includes improper file fetch handling inside of the plugin or theme, which can be used to read arbitrary local files inside of the WP server. So we have several functions that could be useful to identify a possible arbitrary file read vulnerability. First, we have PHP related functions such as file get contents read file, fopen, fread, fgets, fgetcsv, fgetss, which we deprecated from PHP 7.3, file function, and a curl function. We also have WordPress related functions such as WP file system direct class, which have two functions, get contents and get contents array. We basically can visit each of the link to see the details of each function. Example, in this WP file system direct get contents, it basically just a wrapper for PHP file get contents function. So it just read a file and then it will return the content of the file. Now we have example cases. Below is an example of vulnerable code. We will register a WP Ajax action get file, which we will assign a function named Ajax get file. This function is basically will receive our input of URL parameter in the get request to the URL variable, and then it will basically just use WP file system get contents to fetch the URL content, and then it will basically just echo the file content to the user. To exploit this, any authenticated user just needs to perform a post request to the Ajax endpoint, specifying the needed parameter to trigger the WP file system direct contents function. Before we try the example payload, we will set up the breakpoint to the function, and then we will try to execute this example payload. First of all, we need to set the cookie to the authenticated user cookie. We already have a subscriber account, So we're just gonna fetch the cookie of this user from the burp sheet. And then we will set the WordPress base URL to our localhost server. So yeah, now we hit the breakpoint, and it will basically just retrieve the URL and then return the content of the file to us. So yeah, now we have a successful arbitrary file read example POC to read passwd file. We also have some of the findings related to arbitrary file read, such as these articles. You can read it after this workshop. So basically, this vulnerability, it's just using the curl function to fetch the file. Yeah, so that's it. We're gonna discuss about arbitrary file upload that potentially could lead to a remote code execution in WordPress ecosystem. First, we have files input. So one of the way to retrieve a file from PHP is through the files global variable, and another way is through the WP REST request get file params. This is specific for the custom REST API endpoint in WordPress. Next, we have usual functions. We have PHP related functions such as move uploaded file, file put contents, fwrite, fputs, copy, fput csv, and rename. We also have WordPress related function such as wp file system direct, put contents, move, and copy. Next, we have compressed file extraction. So one of the process to upload a file is through an extraction of compressed file such as zip, gunzip, tar, and h. So because most of the time the developer forgets to implement a pre-check before the extraction process, so we could just simply upload a PHP file instead of the compressed file. Several functions that can be used to decompress a file is zip archive extract2, par data extract2, and unzip file. Below is just an example of a vulnerable Ajax endpoint that extract the user supplied compressed file. Next, we have a bypass technique. First, we have MIME type check bypass. So developers often only check for the file's MIME content type without a check on the file extension itself. Several functions can be used to check for MIME, such as MIME content type, EXIF image type, and finfo file. So because of lack of check in the file extension, we could just simply upload the image file with PHP extension with a valid image metadata. Next, we have image related check. So one of the way to check for a valid image is using the get image size function. This function will simply check for the size of the image. Below is an example of vulnerable code. Just check for the image size and doesn't check for the file extension. So just like as the previous case, we could just simply upload the image file with the PHP extension and a valid image metadata. So we're gonna do a demo POC on the MIME type check. First, we need to prepare a valid PNG file. Then we need to append a PHP code to the file. And then we need to rename the file to a PHP file. Then lastly, we need to trigger the Ajax action and upload the malicious PHP file. Alright, file uploaded, and we could just simply visit the PHP uploaded file, and we can test that it execute our shell command. You can also read article reference in this list for further details on the arbitrary file upload vulnerability. We are going to discuss about XSS in WordPress. First of all, we have to discuss about the editor plus or admin plus stored accesses. So WordPress has a default capability or permission called unfiltered HTML. This allows users to insert JS code to some area of the WordPress, such as posts. By default, this unfiltered HTML permission is only given to superadmins in multi-site configuration, administrator, and editor roles. So based on the above condition, we may counter a false positive when testing for editor plus or admin plus accesses. So we need to disable unfiltered HTML if we want to test accesses on those roles. One of the ways to doing this is via the disallow unfiltered HTML constant that we can set to true inside of the wp-config.php file. Below is the example of the configuration. Next, we are going to discuss about the contributor plus stored accesses. So currently this accesses is very popular among the WordPress security researcher. Is because the attack vector lies in the post, in the drafted post, and it could be triggered from other users such as administrator when the user tries to preview the post created by the contributor role user. First, we have a shortcut accesses. So WordPress has a feature called shortcut. So shortcut basically is just a small code snippet that can be inserted to either posts, page, or widgets to display a specific function or content. Below is an example of shortcut for a gallery, and below is the example of shortcut with added attributes such as ID and size. So shortcut is added using the add shortcut function. So below example is example of vulnerable code of the shortcut implementation. By default, the attribute retrieved by the function is not sanitized or escaped from a single quote or double quote. So in this case, we can just break out the class attribute of the a tag HTML through the attribute of classes. So basically we just need to specify the shortcut, and then we inject our payload in the class attribute using a DOM-based style accesses. So let's just try this with a contributor role user. We need to post this shortcut content to the post, and then we need to save the draft. You can see that the class is not escaping the single quote, and when we try to preview the post, it will trigger the accesses for us. Next up, we have Gutenberg block accesses. So the feature is called just blocks or a pre-built elements that can be added to a page or post. So this is actually a built-in feature inside of the WordPress. Below is the example format of the Gutenberg block. So we have the block name, and we have also the block attributes. Similar to the shortcut, it also have attributes. Developers can register the Gutenberg blocks using the register block type function, such as below. So using the render callback function, it will call the function that can be used to display the content. In this case, we have a vulnerable code named custom heading block, which accept attributes parameter, and it will just try to output the heading tag attributes inside of the HTML tag. So similar to the shortcut, the attributes itself is not escaped, so we just can inject this by adding an image and then an accesses payload using the DOM-based style accesses. So we can try this payload. Also, back to the contributor role. First, we need to delete this, and then we could add any blocks in these options. Then we need to intercept the request, and then we try to save draft the post. In the request to the post API endpoint, we just need to replace this with the vulnerable blocks that we previously encountered. So we just we'll inject our payload in the heading tag attributes. Yeah, after that we can also try to preview the post. And yeah, the accesses will be triggered. So next up we have Elementor widget accesses, so similar to the Gutenberg blocks, but in this case it is Elementor widgets. It is a feature specifically crafted alongside with the Elementor plugin. So it's basically just block, but it's called widgets. So similar to it, it is also mostly using the render function that could process the user input on this function. So on the Elementor widget process, they usually call it the settings instead of the attributes, but it is similar to the attributes. The settings itself is not automatically escape from a single quote or double quote, so we can just also inject our XSS payload if there is no proper sanitization on the settings from the user. So yeah, it accepts the settings parameter using the get settings for display. So basically this example function, we could inject our XSS into the settings URL value, which will break out the href attributes. So we could try this also in the contributor role user. Yeah, we need to specify the widget, and then we just copy the XSS payload. Then we try to preview, and the XSS will be triggered. So next we have reflected XSS. So it's just basically a simple type of XSS in PHP in general. So we have some input like the get, post, and request global variable that could be useful to track for a reflected XSS. We also have a server PHP self global value that could also trigger XSS. Next we have admin notice XSS. So admin notice itself is a feature to allow users to show error or success warning message to other user in the admin area or in the WP admin using the admin notice hook. So basically this notice will be shown across of the WP admin area. So if we can control and inject XSS on the admin notice function, we could basically do a reflected or even a stored XSS on a site web of the WP admin area. Below is the example of vulnerable code. We have implemented the admin notice function through the init plugin success function, and then we accept the get message parameter to the message variable, and it will just simply print the message without a proper sanitization to the HTML. So basically we just need to send this link to the any user that is privileged, such as admin, and we can trigger the XSS from this. So yeah, for other resources you can also check below findings articles about XSS. In this section we are going to discuss about local file inclusion or LFI. So this section will cover cases of possible LFI on WordPress ecosystem. This includes improper file inclusion inside of the plugin or theme, which eventually could lead to an RCE on the WP server. We have several functions that could be useful to identify a possible LFI vulnerability. First, we have include function, include once function, require function, and then require once function. We move on to the example cases. Below is an example of vulnerable code. Here we will create a WP Ajax hook with no pref, which indicate that this hook will be reachable by an authenticated user, name renderLation, and we will just assign the function renderLation template to the WP Ajax. This function will basically just accept get parameter of template path, and then it will apply a URL decode to it, and it will assign the input to the template path variable. Finally, it just basically will include the template path variable, and yeah, that's it. To exploit this, any unauthenticated user just needs to perform a post request to the Ajax endpoint, specifying the needed parameter to trigger the include function. Before we try the POC, we will try to set a breakpoint to the function, and then we will try to hit the endpoint to include passwd file. So we gonna set the WordPress base URL to our localhost installation, and then yeah, the template path, and then it will include our template path. So yeah, we will have a successful LFI POC, which will include an passwd file. In worst cases, this LFI could lead to an RCE if user is able to fully control the strings to the include function. So below are some of the findings related to local file inclusion. You can read the details after this workshop, but we will try to take a brief look at one of the article, which is an LFI in the Ocean WP theme. So yeah, this vulnerable code basically the load theme panel pane will accept post parameter named slug to the slug variable, and then it will supply the slug variable to the print pane function. In the print pane function itself, the slug will be constructed as a file path, but without a proper sanitation or filtering. So the file variable will be included to the application using the include once. With these cases, of course, we only can include an arbitrary local file .php file. So the worst case scenario would only can appear if we have some control of or full control around a PHP file on the server. So yeah, that's it. Now we are going to discuss about a privilege escalation in WordPress. So this article will cover possible privilege escalation on WordPress, including several processes inside of the plugin or theme that can be used to escalate user privilege or role. Privilege escalation in this case also includes an account takeover case. The first case is arbitrary option update. So WordPress has an options feature, which is simple and standardized way of storing data in the database. We basically can insert any data into the WP options table under a given custom name. Two of the default options available are the users can register and then the default role options. The users can register option itself will decide if the site accepts an open user registration. By default, this option is disabled. The default role itself is an option to decide the default role for the new user upon registration on the site and has a default value of the subscriber role. To update an option, we use update option function. If a user can fully control the option and the value parameters, they can achieve a privilege escalation by enabling the users can register option and setting the default role option to administrator. So the registration feature is open and anyone can register with an administrator role. Below are the example of vulnerable code. Here is the nopref WP Ajax action for update site preference. The function is simply accept post key and value parameter, and it will pass to the update option function. To exploit this, any unauthenticated user just need to perform a POST request to the Ajax endpoint and specify the users can register, and also set the default role to administrator. So we already set up a breakpoint on each of the functions in this privilege escalation cases. So let's try to execute this payload. First, we will set the users can register option to true. This is to enable the user registration feature. Just need to change this WordPress base URL, and then yeah, after that we just only need to perform a crawl request to change the default role to administrator. Okay, all done, and we can confirm it in the admin panel in the settings general, and we can see that the anyone can register option is enabled and the default role is set to administrator. We can test this by just try to register an account. We just fill out any username, and yes, the registration is complete, and we will need to verify our email. But if we see in the users sections, we can see that our newly created user have an administrator role. Okay, so we move on to the another case, which is arbitrary user meta update. So according to the official documentation, WordPress users table designed to contain only essential information about the user. Because of this, to store additional data, we need the user meta table. This user meta table actually contain a WP capabilities value. This value is just an serialized object of role assigned to the user. Example is this string, which indicates that the user have a subscriber role. To update the user's meta, the update user meta function is used. If a user can fully control the meta key and the meta value parameter of the function, they can achieve a privilege escalation by either updating their account if the user ID parameter cannot be controlled, or any account if the user can control the user ID parameter. Below are the example of the vulnerable code. We will assign change user bio to the WP Ajax function, and it will basically call a update user meta function to the user ID, which is set to the get current user ID. So we can only control the bio key and the bio value. This means that we are only able to do a privilege escalation in our own account because we cannot control the user ID. To exploit this, any authenticated user just needs to perform a POST request to the Ajax endpoint, specifying the key for the WP capabilities and the administrator set to true. Okay, so we can try this payload. First of all, we need to have a valid cookie for an authenticated user. It could be any user. For this example, we're just gonna use the subscriber role account user. We will gonna grab the cookie from the worksheet. Okay. And then we change the base URL. As we can see, the bio key and bio value is fully controlled by us. And then after the request is sent, we can try to reload the subscriber pin panel. And then you can see that we have now capability of administrator on the WP side. You can also confirm this by checking the users. So yeah, we have now the administrator role. Next cases is unrestricted user registration. So many plugins or themes implement a custom user registration process. This case mostly found in Page Builder. One of the ways to register is using a WP insert user, which will accept user data parameter. One of the value insert of the parameter is role value, which determines the role of the inserted user. Another value would be a meta input value, which can be filled with custom user metadata, which can also result in a privilege escalation cases. Example of vulnerable code: we create a WP Ajax no priv action for an open registration. It basically will accept a role parameter via the rec role post parameter, and then it will just simply perform a WP insert user to the user data object. To exploit this, an authenticated user just need to perform an Ajax request specifying the needed value such as name, password, email, and then setting up the rec role value to administrator. Let's try to exploit this vulnerability. So we're gonna change the base URL value to our local installation. Yep. Alright, it will call the WP insert user with the role administrator. Yeah, we can confirm it by checking the users list on the admin panel, and we can see that we now have a pwned user with an administrator role. Next case is unrestricted user update. So it's similar to above cases, but instead of user registration process, this case involves updating data on the user's main table. So one of the ways to update a user's main data is through the WP update user function. This function accepts user data parameter. It's also the same. Inside of the parameter, we have a role and a meta input value, which can be used to escalate our privileges. The example vulnerable code, we have a custom update profile function, which will iterate the post data parameter, and then it will update the user data using the WP update user function. So basically, to exploit this, any authenticated user just need to perform a post request to the Ajax endpoint and specifying that the role that we want. In this example, if we want the administrator role. Let's copy this example payload. We will fetch the subscriber role account first. Yeah, first of all, we need to update the subscriber role because previously we already do a privilege escalation on this user. So just change it back to the subscriber role. Yeah, and then we grab the cookie. Okay, then we have to change the WordPress base URL. So yeah, we are now in the function. It will iterate the post data parameter, and then it will update the user data using WP update user, and it will set the role to administrator. After the request, we can confirm it by visiting the all users again, and then we can see that the subscriber account now again have an administrator role. It is also possible to update a user password by specifying the user pass value in the user data parameter array. This could also lead to an account takeover if we can control the ID value of the user data parameter to specify the targeted user. Other than that, an attacker can also modify user activation key, user email, or user login to possibly take over their account. Next up is insecure password reset. So one of the ways to reset a user's password is using the reset password function. This function accepts a user parameter and also the new pass parameter as the new password value for the user. The function itself is just a wrapper to another function, wp set password, which is the core function to set the new password for the user. This function accepts the user ID parameter and the password parameter as the new password for the user. In this example vulnerable code, the reset your password function, it basically will set the password of the user ID, which is a get current user ID, using a new password value from the post parameter. To exploit this, we need to host, since this is a CSRF like cases, so we need to host a HTML payload like this one, and then we need to trick the targeted user to visit the link that hosts this HTML payload. So yeah, I already have the HTML payload, and it will set the new password to value change 123. You can try to host this HTML payload in localhost, and then we can trick the administrator to visit this link. Yeah, now we are inside the function, and it will set the password to the change 123. We can confirm that with the session expired and we cannot log in with the old password. We can only log in with the newly set password, which is change 123. Yeah, now we are logging as administrator. We have the last section, which is insecure authentication cookie set. But in this workshop, we are not going to discuss about this, and you guys can read this further and try it as an exercise. Also, if you have time, you can read also on each cases. We have several findings in our article that mention the vulnerable cases. Now we move on to the server-side request for query, or SSRF. This section will cover cases of possible SSRF on WordPress. This includes improper URL fetch handling inside of the plugin or theme, which can be used to perform unauthorized action or access to data within the organization. This can be in the vulnerable application or on other backend systems that the application can communicate with. We have several functions that could be useful to identify a possible SSRF vulnerability. First, we have PHP related function, which include file get contents function, read file function, fopen function, stream get contents function, file function, and the curl function. We also have WordPress related function such as wp remote head, wp remote get, wp remote post, and wp remote request. So basically for wp remote head, get, and post, it will basically perform a head or get or post method to the supplied URL. Example cases. Below is an example of vulnerable code. We registered pajax nopref function with fetch image URL. This indicates that this function could be reachable by an unauthenticated user. This function basically will try to perform a wp remote get, which will perform a get request to the supplied function through the get image URL parameter, and then it will retrieve the body and finally it will echo the body of the URL that the user supplied. To exploit this, any authenticated user just needs to perform a POST request to the Ajax endpoint, specifying the needed parameter to trigger the WP remote get function. Before we jump into the example payload, we will try to set a breakpoint to the vulnerable function. And then before that, we want to create an example of a local server in our local installation. So yeah, for example, we will try to post a secret.txt file inside of our local installation, and then we will host the file just using the basic PHP server listen in port 9897. And then we will try to execute the example payload. First, we need to change the WordPress base URL to our localhost installation. And then we will specify the image URL to the local service that we previously created. So in this case, it will be localhost 9897, and we will try to fetch the secret.txt file. Alright, now we are inside of the function. So it will basically perform a GET request to the supplied URL, and then it will return the content of the secret file to the users. So yeah, basically we can fetch local network service in these cases. Below are some of the findings related to SSRF, and you can read it also after these workshops. So yeah, that's it. Now we are gonna discuss about SQL injection or SQLi. This section will cover cases of possible SQLi on WordPress. This includes improper usage of functions and user input handling inside of the plugin or theme, which can be used to inject a malicious query into the SQL execution to leak sensitive data on the WordPress database. We have several functions that could be useful to identify a possible SQLi vulnerability. First, we have WPDB query, which basically will perform a database query using the current database connection. Next, we have WPDB getVar, which will only retrieve one value from the database. Next, we have WPDB getRow. This one, it only will retrieve one row from the database. We also have a getCall function. This function will retrieve one column from the database. And last, we have the getResults function, which will retrieve an entire SQL results from the database, and it can have many rows on the results. Example cases. Below is an example of vulnerable code. So we gonna register a WP Ajax nopriv load question, which basically indicates that this function is reachable by an authenticated user. So yeah, this function basically will retrieve a quiz ID from the get parameter into the quiz ID variable, and it also will set the question SQL variable if we set the cookie of question IDs concatenate to the quiz ID that we previously supplied. The cookie value basically will be performed using the WP unslash, which will remove the added backslash to the cookie value, and then it will perform a sanitize text field to the variable. Next, the question SQL variable will be concatenated to the order by SQL variable, and then it will construct a query variable which will concatenate the question SQL variable previously, and then it will just simply execute the SQL using the getResults function, and then it will output the results to the user. So the vulnerable variable in this case is the question SQL variable, where the value is passed from the cookie without the proper sanitation or escaping. The sanitize text field function itself is not enough to prevent SQL injection, since the question SQL is constructed inside of an order by clause without a proper escaping. To exploit this, any unauthenticated user just need to perform a GET request to the Ajax endpoint, specifying the needed action and parameter to trigger the SQL injection. In this case, let's say that the affected tables, which is a custom questions table, has 5 columns. So before we try the example payload, we will set a breakpoint to the affected function. Then we will copy the example HTTP request payload. So basically the payload will contain SQL injection payload, and it will perform a union select with a 5 column on it. It will try to lick the database name and then the user that operates the database. So yeah, we try to send the request. We are now inside the function, so the quiz ID will contain value 1, and then because we set the cookie to our injected payload, the question SQL will contain our SQL injection payload. So it will concatenate it to the order by SQL variable, and then it will construct the query variable using the wpd prepare function, and it will fetch the results using the getResults function. So you can see that we are able to perform an SQL injection. In this, we are able to lick the database name, which is a WordPress, and then we can also lick the user that operates the DB, which is WordPress at localhost. We can also read some of the details of the findings related to SQL injection. We have several ones in our articles. Of course, you can read it after this workshop to familiarize about the SQL injection. That's it from me and the vulnerability section. We are gonna back to Ananda to discuss about the CVE reversing section.
Hello everyone, I'm back again with the most interesting and the most exciting topic in this workshop, and that is CVE reversion. So now that we've learned about all the vulnerabilities, all the ins and outs of WordPress, we finally can go ahead and take difficulty level to an extra step and do some CVE reversion. So what is CVE reversion? CVE reversion is basically the process of creating POC by diffing the vulnerable and the patched version. For an example, let's say one of the entries was published by patch stack that says something like this: WordPress master selector plugin is vulnerable to PHP object injection in this version, and it was patched in this version. So basically what CVE reversion is that we take these two versions, take the code differences in these two versions, and figure out the proof of concept for the vulnerability. So we've already discussed the track feature, which we'll be using to find the difference in the code. We don't need to download the different versions of the plugin and get the difference manually. We can just browse through track and look all the chains between the vulnerable and the patched version. So how to reverse the CVE? So yeah, it's simple. We just use the track feature. We diff the patch. So we do have some steps for CB reversion mentioned here, which is basically the same. And we do have some demo as well. For this workshop, we'll be doing the demo for WordPress registration magic plugin, less than equal to 5.2.4.1 reflected access vulnerability. So we know that it was vulnerable to XSS below and equal to 5.2.4.1, and it was patched as this version. So what we need to do is we basically need to get the plugins log and browse to plugins.track.wordpress.org and browser/the plugins log. So we have this page right here, and we need to go through the trunk revision history. So it's taking a while to load. And then we can see that we do have the version 5.2.4.1 and 5.2.4.2. So what we need to do is grab the changes between these two versions, view changes, and yeah, we can see all these files that were changed between those two versions. So we're specifically looking for XSS. We're looking for reflected XSS. So we need to look for all the echo command that are being used in the changes and see whether there were any sanitizations that were done. So we have this change log of all the versions of the plugin. So if we look for the echo, so we can see right here, PSP echo get section ID dot click, and it was fixed by adding the esc_html function that basically sanitizes the user input section ID parameter. So from here on, we can just browse to this file, and then look through how we can call this file, call this specific line of code, and we can move towards upwards from that way to get a fully working POC. We will not be doing the full POC in this workshop though, so this is left as an exercise for the researchers to work on and get the POC. So thank you everyone for sticking around till the end. This is the end of the session for Acing WordPress with code review. And before we hop off, we do have a bug bounty program at passtack.com/bugbounty where you can earn cash reward for reporting vulnerabilities in WordPress plugins and themes. And make sure to check it out. And we do have a Discord community as well, which you can join. And if you have any questions as well, we do have general discussions revolving WordPress security. And yeah, if you do have any questions, please let us know. We'll be happy to answer.
All right. Thank you to the Patch Stack team for doing that. I noticed in the comments there were a lot of issues with the quality of the stream. So if you're having problems, please do me a favor. We see that Twitch is doing way better than YouTube is. So if you are able to watch this on Twitch, head over to twitch.tv/NahamSec. It may be a little bit better if you go and watch it over there. So just a heads up, it's just a problem with YouTube, it feels like. But we're also going to remove the layover for the next talk. So this way you have a larger screen and a little bit more on the screen to look at. So that is something that we're going to fix in just a couple of minutes. Otherwise, we're going to take a quick break and we're going to come back live in about 15 minutes with Alex doing his how to bypass WAFs. This is also pre-recorded. It is also very much lab driven. You'll have access to the labs. He's going to go through them with you. I think he's going to be in the chat. Again, we need to make sure these labs work. So if something goes wrong when we are doing these live, then it's a bigger problem. So that's why we have them all pre-recorded. But Alex will be around, I think, in the chat as well. He was talking about this. It was talking in the chat earlier. So quick break. If you're here in 10 minutes, we'll be back with Alex's talk. So hang around and we'll be back. All right. How are we doing? Everybody still there? Any bug bounty hunters in the chat? If you're a bug bounty hunter, let me know in the chat, because even if you're not a bug bounty hunter, you're a web pen tester, this next talk is very, very important. And I think it's a ongoing theme for NahamCon, starting with this talk. And then tomorrow we have two other ones, I think, around the same concept of bypassing WAFs. And Alex is actually going to be our next speaker. He is a hacker and a bug bounty hunter. He is a specialized hacker in pen testing of web applications and bypassing security protections. Alex is passionate about hacking, and in his spare time, he does security research. So, with that said, let's welcome Alex to the conference. But before I do that, just make sure you guys go to the link down here. There's a link for the WAF Bypass Labs. If you want to follow along, it will be there. Just go ahead and sign up. Also, we removed all the limitations of the talk, so the screen should be better. But if you're watching this on YouTube and you're still having issues, please go to twitch.tv/NahamSec.
Hi everyone, this is my presentation, The Art of Bypassing Web Application Firewalls. So to start off, this is the content we'll be including. We'll be including a short introduction to myself, who am I, the goal we'll try to reach during this presentation. We'll be going through the basic of the web application firewall and how it works, for those of you who are not too familiar with it. We'll go through the Dojo platform, which will be used to host our simulated WAF that will be used for our practical labs. The bypass methodology on how a payload is created, and the methodology I come up with myself that I use now for maybe 2-3 years. That's been extremely, it works extremely well for me at least. And an exploitation techniques on how filter collision works, and how you can bypass using this strategy, and transformation, for example, excluding spaces in your payloads, and also encoding strategies to manipulate the firewall itself. And at last, we will go through the conclusion of the full presentation. So to start off, who am I? I'm Alex. I'm also known as the Hacker Brumans. I work at JessWhack as a researcher. I'm also a hacker, bug bounty hunter, and a developer. So to cover the goals on this presentation, we'll be going through on how to understand the WAF application firewall's blind spots. We'll go through the mastering a new bypass methodology, which is the one I come up with myself. Understanding different bypass technologies that you can use. Create your own customized payload adapted to the firewall that you're facing. So to start off, on the left you can see the SQLi, which is the laptop. In the middle obviously is the firewall with the little flame. You can see on the right you see the server with the web application that's hosting the web application. So when you're sending your payload like this, the firewall will either let you through, but if it detects that it's malicious, it will decide mainly on those 3 categories. So it will either send you a forbidden page, it will block you, or it will drop your request. And that will be, if you drop your request, it will be hard to detect if it's the another proxy, the firewall, or the actual web application that triggers some error. So how the firewall does this is it's using regex, black, and white lists. So a regex is quite easy. It's a rule that is based to detect patterns within your payloads. So it can support a wide range. So for example, on the left you can see a template injection payload, and on the right you see the rule, which is a $sign, a curly bracket, and if it continues until the end of a closing curly bracket, it will be treated as malicious. And as your payload contains a template injection payload on your left, which is red marked, you can see it's got triggered by the firewall, and that is treated now as malicious. So the black and white list works like this. On your left you can then XSS payload, which is having the on arrow keyword, and the firewall will extract all these keywords, for example image, src, on arrow, and alerts, and it will check all these words within its list and see if it matches any of the keywords. If it matches a keyword within this list, for example a blacklist, or it's not matching a whitelist, it will treat your payload as malicious and block you. So now that we have the very basic of how firewall detect you, we will go through a practical lab that we will be using for our labs, and that will show you how you can bypass the firewall, and also how the firewall blocks you in different scenarios depending on your payloads. So to start off, you're having the Do platform, and it looks like this. So this is an example of the filter collision lab that we'll be trying out later in this presentation. On the top left you can see user input, which is where you actually write your payload. Next to that tab you have an inspect tab. That tab is used to, for example, if you click on any on the regex or the protection mechanism, you will be able to inspect and see where your payload got triggered by the firewall, to more easily point you to the direction on where your payload is detected, on what part, instead of having your whole payload being detected. So it's giving you more details. On the bottom left, or on the middle left, you can see the lab description, and you can see the goal of the lab. At the bottom left, now you can see hints to point you in the right direction during the lab. You will have the source code, which is a very simple source code. In case the firewall actually detected you, as you can see WAF_blocked, it will give you the WAF.html file back, otherwise it will give you the index.html. So on the right you will see the rendered response. In this case it's the firewall that got triggered, and you will have the forbidden page. And if you look at the red mark window on the top right, you will have an eye icon together with an icon like a code icon. If you switch between those, you can see the source code and you can see the render page. Currently it's the rendered page, and it's marked as green on the top right of the red window. So in this tab here is the most important part, which is the actual firewall. And you can see from the left you're having your red input, and you will have the lines on how your payload is transformed all the way to the output on the right. So first it goes through a blacklist, then it will go through a regex, and then another regex, and then it will go through a URL encode. And you can ignore this last part with URL encode, because it's only used to not actually be able to write pure Python code within the source code itself. So you can ignore the URL encode at the ending all the time. So with that said, I'm going for a short demo on how the platform actually works, and we'll guide you through it with an example lab. Okay, so when first opening the demo lab here, it will look a bit different. You can see you don't have your input, or you actually have your input, but it's in different tab like this. You can actually drag these tabs. For example, I drag it here to the bottom, similar to the way that I recently showed you. And now it looks similar. You can also take these tabs over here. You're having the source code for the challenge, and you're having the result, which is no response because you haven't sent any payload yet. But you can take this result and drag it to, for example, to your right here. And when you send your payload, it will render the page for you for the challenge. And on the left here, on this window, you're having a little code icon. So if you click on this one, you will see the source code of the actual challenge itself. So, and here you will see the firewall, and you can see our input is this one. So when we're sending our input, it will go through a blacklist first. If we write something, for example, we can write performance, sending our payload, you can see it's the same as it was in the original payload. So it hasn't been modified or detected by firewall. So if we send this one, it should be fine. Render. Okay, we're good to go. If we, for example, check this blacklist now that the firewall use, you can see it's having a simple blacklist with alert, confirm, and prompt. So if it contains, if the payload contains any of these keywords, it will get blocked. So we can do, for example, alerts at the end, and you can actually see now Bruman's alert and Bruman's WAF blocked. So now we see that our payload got blocked, and you can see it here on the right. So this helps you understand that Bruman's itself is not the trigger of the firewall. It's not what's triggering. The trigger here is the alert. So it helps you more analyze and understand the details why the firewall blocked you and what part it blocked in the payload. So the goal here, if we read, will be to exploit an XSS and bypass the firewall. So if we do a simple XSS here, I believe we are inside a value tag. We're going to see test. You can do Control F here, will pop up, and you can search for it, and you can have test. You will find test here in the value section. Okay, so we're going to see if it's vulnerable, and obviously yes, it's vulnerable with cross-site scripting. We're going to try exploit it. Unload alert, boom, boom, and we will obviously get blocked because it's containing the alert keyword. So if you click inspect, you can see here, dragging down, it's containing the payload, and you have an alert. So the full payload is working fine, except the alert that I showed you before. So instead, we can use something simpler, like print. And we're sending this one. And this is an important note. The payload will not trigger if you're having the code section marked, because the page have not been rendered. So if you click on the rendering icon or the eye icon, you will see our payload popped. So that's the short introduction on how the platform works. So back to the presentation. Okay, so now that we've gone through a live demonstration of the Duo platform itself and how we can use it for a practical lab, we will be going through the bypass methodology. So the bypass methodology itself will be starting off this. So this will be a very simple image or illustration of how it will work. So on the left you will see your laptop. It will sending a payload to the firewall. So imagine this payload, for example, is a full template injection, SQL injection, XSS payload or whatever. It's getting detected by the firewall. And the firewall responds you with a Boolean response with like yes and no, depending if it's giving you a forbidden page, blocking you, or timeout, for example. Or if it's giving you the original response of the web application that is vulnerable, you bypass the firewall. Quite simple, right? So we will use a methodology like this. We'll send first, the very first time we'll send a full payload. The full payload will be, for example, a full payload like image src equal x on arrow alert 1. Okay, cool. So we will send this payload here. We will ignore updating it because it's the very first time we're sending the payload. We will see how the WAF treats this payload. It will most obviously block it because it's a very easy detected payload. And we will have to decide what triggered the actual payload, like what part in the payload is the actual trigger. So as an example, if I have a SQL injection and we want to send a payload to the application to sleep for a second to verify that it's actually vulnerable, you will use a payload like this. So single quote or sleep for a comment away the rest. The very first time you're sending this, it will, in 99%, if there is a WAF application firewall in place, it will get blocked. So, but because it's the full payload, we actually getting blocked on, we don't know the actual part of the payload that is blocking. Like, is it the or, is it the sleep, is it the single quote itself, or is it the comment? Like, what section of the payload is actually getting blocked by the firewall? Where is the trigger? So we need to verify the trigger, and to do this, it's not possible the first time. But if you continue with this methodology, like this, I will show you. You're having the payload, you take it down into all its sections or all its different parts. So you will have your single quote, you'll have your space, you'll have the or, sleep, parentheses, the value within the parentheses, and the suffix, which is the comment. So as you can see here, we have the prefix, we have the space, we have the keywords, that is the SQL keywords, the parentheses, we're having the int, which is the value within the parentheses that sleep is using, and we're having the suffix. If you just look at this payload, the first thing that you probably think is the trigger, which is probably the sleep. So, and that's probably true. Like for me, the first that I see is, okay, a quote combined with or. That's in most cases a SQL injection payload, so it's probably that's probably why it's getting blocked, right? So that's one problem we're probably having. The other one will be, as I mentioned, the sleep. When it's combined with parentheses, it will be treated as, okay, it's a SQL injection payload. Okay, so probably something like this is the trigger that's triggering the fireball within our payload. So how can we make this payload more like confusing for the fireball and manipulate it in some way? Like how can we make sleep into something that the firewall do not see as sleep? So you can use something like a table like this. So a single quote here at the top left, it can be, or everything basically in most cases can be encoded to URL encoded, depending on where your input is. And for the spaces, which is quite interesting, this is most of the time the space is actually the thing that you can manipulate and cluster things together to actually confuse the firewall. So it can be a lot of things. You can have tab, you can have new lines, you can have multiply comments instead of spaces. You can have parentheses, which I will go through in next slide. Instead of or, you can have XOR, you can have or with uppercase and combined with lowercase. You can have the or operator, depending on your SQL. Sometimes it means concat as well, so you have to know the database to actually use this. These pipelines. And the last one, which the one I like the most, is you actually taking advantage of where you're infecting your SQL injection payload in example. So if this is inside of a where statement, instead of using or anything else, you actually take advantage of the actual value that you were escaping from. So you're taking, for example, if this was an int-based injection, so for example, we're inside an ID, which do not need a quote, you can take equal to, and parentheses, a full new statement that you knew will be true or false. For the sleep, you can use uppercase combined with lowercase, or you can use a total new keyword like benchmark to see if you get a time delay from the application. As parentheses, you can encode into URL, you can nest them into multiply parentheses, and you can also use something like this at the end. You can combine it with comments to actually see if the firewall is trying to see where it finds the closing parentheses. So for example, if it sees the first parenthesis, it will look for the closing parenthesis, and depending on the configuration on the firewall, it might actually see the parenthesis, the closing parenthesis within the comments instead of the one outside the comments, which you can use to manipulate and bypass the regex. 4 is also like values or something that you can manipulate a lot. Like a 4, you can take 6 minus 4. You can take 4 bitwise to 0, which will be 4, depending on your SQL again. And you can take minus true, which is equal to 1. True is equal to 1, depending on SQL, but you get a point. So minus true multiplied by minus 4, which will result in 4. Or you can take true plus true plus true plus true, which will be 1 plus 1 plus 1 plus 1, which will be 4. You can also use the comment instead of doing double like minus signs. You can use, for example, a hashtag. So remember the payload we had first, which is a single quote or sleep 4. If we want to take advantage of this we just looked at, we can make a payload similar to this. And I made them for you to understand it much better. I made them in different colors and different Boolean values for you to understand, but I will go through it. So the payload that you have first was the single quote or sleep 4. This payload underneath is exactly the same, or it's obviously not the same, but it's doing the exact same exploitation. So as you can see, it's or sleep true multiplied by 4, and then comment away new line. Okay. So the reason why it's combined with this, it's using this, is because if you look at the first that we thought was our trigger, we're now going to test if this theory is actually true. We're going to send this quote combined with the OR sign. And if this is not getting triggered, we know that the firewall is relying on spaces to actually see separate pieces of your payload. If it's still triggered, then we'll go through the process once again with a new theory, and then we'll continue. But to go through this payload, this one is combining the space, or just removing the space in the first section. Then it will use a parenthesis, which is green. And that is because everything that is green is instead use of spaces. So, or instead of space, you're doing a parenthesis with a new SQL statement, which will be sleep. Then the pink one represents the one that sleep is holding, which will be true multiplied by a comment to trying to confuse the regex 4. So this will total result will be 4 as a value. Then it's closing the parenthesis that OR started, and it's adding the comment at the end. And instead of a space, we're going for a new line. So the methodology over here will be, we will try this payload again that we construct, but now instead of doing the full payload, we will just see if the actual first section will be triggered or not, because if it's getting triggered, we'll have to modify the payload once again. So we're sending the first OR statement to actually see or test our theoretical theory if it's the trigger. So if we're sending this here, the payload, it will get blocked. So this proved that our theory works. Okay, so the trigger is actually when the single quote combined with the OR, then it's actually treated as a malicious payload. Okay, so now we know this. So the payload is triggered when the prefix is set to a single quote mark and combined with a keyword like OR or uppercase OR, and that continues with a special character. That's what we know currently of the firewall. So to test this, if it's correct, we'll send it without the parentheses. Okay, so we're sending this without the parentheses this time, and you can see we got bypassed. So this means that everything that comes after OR, if it's a special character, it doesn't have to be any special character, but in our case it was the parentheses, it got blocked. So what we need to do now is we need to try to come up with a solution what we can use instead of the parentheses. So as described here at the bottom, the WAF triggered when the blacklist keyword uses a special character afterwards, as I said. And that will result in this table. So our payload now bypassed, but the other one did not bypass, which got blocked. So our theory is correct. So the trigger is here within our payload. So now how can we bypass this? And this is for more like extreme cases, because we will be using filter collision, transformation, encoding, or excluding spaces, as you recently saw. So we'll go through all of these techniques and how you can use them combined with these recent techniques that you learned. So, filter collision. Filter collision is, for example, it's very similar to transformation, but it's when you're sending a payload and something within the application itself is doing some modification within your payload. For example, if you can see here at the top right, you're having a source code, very simple snippets. It's taking your Q parameter in the get and get parameter Q, and it's replacing every double quote with nothing. So it's removing them basically. And then it's reflecting to the page your value. If you're sending something like the payload example here, which will be marked in red, your quotes will probably bypass the firewall because this payload makes no sense, right? It's S, okay, special character, VG, on, special character, load. So it doesn't make sense for the firewall to actually block you because the payload doesn't work by itself. But what you do is you're exploiting the actual filter within the backend, and that filter is making this firewall confused. So when you send this to the firewall, it will see this one as valid. But when it reaches this code, it will be converted to the actual page you want, which will be the SVG onload alert comment. And that one will trigger. So, to demonstrate this, we will do a practical lab and see how you can take advantage of this. Okay, so we're now on our first real lab, which is the filter collision. So in this lab, we're going to take advantage of the filter collision. And we're going to read the description here. The firewall will detect a certain amount of patterns when the payload is handled by the backend server. The payload will be filtered and modified before being reflected in the response. Okay, so if we send something like test here, we can see, okay, it's reflecting test right here. We will see the source code, and you can see test is reflected right here. Cool. So we're just going to send a quick payload and see. Sending this, and we're getting blocked. But it's pretty obvious, right? It's quite an easy payload to detect. But we wanted to see why we're actually getting blocked. And you can see here in the workflow of the firewall, we're getting blocked at the very first blacklist here. If we click on this one, here, I can click inspect. You can see it's blocking alert, confirm, prompt, console, print, and from. And since our payload contains alert, this will be the trigger for this current filter. Okay, so that's our first problem. The second problem is within this one. If we check the next filter, in here, if it starts with an arrow sign, continues with a ladder, it will get blocked. And since our payload has the image tag here, it's actually starting with an arrow sign, continues with the word image, which is a letter or letters. So this one will get blocked, and this one was already blocked before. Okay, and the next regex will be on. So everything that starts with on, a new line, or anything else, and end with an equal sign will be treated as malicious, so it will be blocked. So in these cases, we had the on arrow, and you can see at the bottom it's getting blocked directly. So we're having currently, the only thing that works on our payload is the first prefix and the suffix. The rest is blocked. So if we look at the source code of the vulnerable application, you can see it using a filter as well to actually try to protect itself. It is removing all the arrow signs, opening and closing, before it's being reflected. We can try this one out. So we're going to send a new payload, which will be test, closing sign, X, opening sign, sorry, closing tag, and then, for example, send it. And we're still getting blocked, and that's because this, remember, if it's starting with a letter with an opening tag, it should be malicious, or it is malicious and will get blocked. So we will have to switch this tag over here, send it to the end to make sure it's not having a letter. We'll submit it. And you can see now in our response, it's actually removed the arrow signs as expected. And if we check the source code, you can see it's actually removed. So we confirm, okay, so the filter did work in the backend, it's removing our arrow signs. So how can we now combine this filter or take advantage of this filter to actually bypass the firewall? And as you saw, you can actually see here we are inside a value within an input. So we first need to ask ourselves, what do we actually need? Do we actually need arrows? No, we actually do not, right? We're inside an input tag. We could use something like autofocus, onClick, etc. But in this case, it's actually not specifying any type. So it's not a type search, it's not a type text or email or whatever. So it has no type, which means if we're able to escalate outside here, we're able to specify our own type. So we can try to do that, right? Escape it, and we'll do type equal, for example, image. If I send this one. Okay, cool. So we specified an image type. It's having, yeah, it works right. So if you didn't know this, if the input is not specified with type, and we're able to specify the type ourselves, for example with an image, it will act like an image, kind of. So if we now give it an invalid src like a source, we can trigger on arrow within input, the input tag itself. So what we're going to do now is to do source equal to x, for example. And it's not getting triggered as you see in the workflow. It's all good, right? So what's actually the real issue here in the firewall is, first of all, the blacklist, and also the regex here with onload statements. So what we need to do is we have to come up with a way to actually do like an on arrow, as you can see, equal, and then we'll have a JavaScript over here. This on arrow is getting blocked here. So we can use this filter here, because remember, it's actually removing the opening and the closing arrow signs. But if we're using the opening, this filter here will trigger because it's an opening combined with letters. But we can actually use the closing tag. So if we use the closing tag and check the regex, it needs to have the word on. This word here, the on, has to be there for the regex to work. And you can see in our payload we have it here. What happens if we actually adding a closing arrow sign here? You can actually see, okay, it bypassed the firewall. The payload currently does not work because it's having a syntax error here. But this filter should remove it, right? Because we verified it before. So if we send this one here now, okay, we're checking the source code. X, we escaped, type image, src equal to x, and on arrow. So we bypassed the firewall and we're able to actually have an on arrow statement within this vulnerable application. Cool. So what we can do now is it's ending with, for example, our quote here. So we can start with a quote. And what we want to do is we want to have like an alert. So alert once again was blacklisted by the firewall in the blacklist right here. But once again, because it's removing the arrow signs, you can actually just combine or add this one randomly within the string. And it's actually bypassed here within the section here. As you can see, it should be blocked now. Let's see, you don't see it here, but you can move this one actually, and you can see, okay, it's blocked. So what we want to do is want to add one here as well. We're going to do one, and then you can send it. And it looks good to go. Now we're going to run there, see if it works. And it works. So we now exploited this by taking advantage of the invalid filter and took this filter, combined it with our payload, and then used it to bypass the firewall. And to my surprise, this is actually a very common scenario, because when it's a vulnerable application, it's actually making some misconfiguration in the filter itself, or it doesn't have a filter. When it have a filter that is invalid, this is most of the time the case. So it's actually removing something, or it's replacing it with something weird. And you can actually take advantage of this, as you saw now in this lab, to actually bypass a pretty well protected firewall by just exploiting the vulnerable section that you're trying to exploit, because it's using some invalid filter on configuration itself. So now that we've gone through the filter collision lab, as we did here, we will go to the next technique that we can use, which is transformation. Transformation is quite similar to filter collision. Like, it could be, in some scenarios, it could be like almost identical. But transformation, in my eyes, is more like it's transferring something rather than deleting it. So in this case, you're sending a payload, as you can see, which is a template injection payload. It's hex encoded. It contains the, you can see over here, the red mark. It contains the curly brackets in hex encoded form. So if we look at the source code at the top right, you can see it's data equal bytes, user input, which will be your payload, UTF-8, which is the char set. It will decode it, and it will having an argument Unicode escape, which basically means that when Python will decode this byte, it will actually include escape character and make them to its original characters. So if you're having hex version of the curly brackets here, you can see it will be transformed into curly bracket itself. So when it's reached the firewall, then reach the filter here, it will be transformed into the payload that you expected. So how can we use this one now to actually bypass firewall? We will go through it a bit quick in a lab. Okay, so now we're going to bypass this firewall by using transformation. So within our payload, something will be transformed. As you saw on the example before, when we send a hex or Unicode, etc., it will be encoded into original character that we want. In this example, it's the same. If we look at the source code, just to see the vulnerability, it's vulnerable for a server-side template injection. So we're sending our payload right here, which will have our value. If it contains WAF blocked, which is if the firewalls detect something, it will return the firewall page. Otherwise, it will take our data, convert it to bytes, and over here it will decode it and have the Unicode escape argument. So this allows the actual payload or a payload to transform. If we do a hex or Unicode, it will be transformed into the real character. So then it will take this page. So here's the actual real vulnerability of the template injection. It's taking page and it's going through the environment, which is the top here. It's getting this file, which is initial.html, and it's rendering it, and the output variable within this file will be replaced by data, which will be our decoded payload right here. The actual issue is right here. It's printing out the content, and it's using Jinja to actually take a string, which will be the page itself, the page content, and it's rendering it one more time. So if our payload contains server-side template injection payload, it will execute it. Okay, so that's vulnerability right here. So we will take advantage of this behavior right here, which allows us to have send hex encode or Unicode, and it will be transformed into the real character. This will also happen, for example, if you're inside an evil statement in a vulnerable application and you send a hex or Unicode, it will be the same effects. So if we try here, just sending a test, we want to see the reflected input. It's the same reflected as before, it's in the value. Okay, cool. We're going to check a bit quick on the firewall here. So it sees, if it's not see a letter, uppercase or lowercase, a digit or underscore, if that's not our character combined with a curly bracket, a regular bracket, or a parenthesis opening, it will be treated as malicious and it will get blocked. So our goal here will be to bypass the firewall by exploiting the transformation that occurs in the backend of the vulnerable application. Okay, so we will first try just to trigger the firewall. So we can do this if we do, for example, it should not trigger if you do a curly bracket, and you can see it do not because it's actual letter T. If we do, for example, a dot, it's triggered because it's a special character. Every special character, for example, here will get blocked. So $sign or 2 curly brackets in a row will get blocked. So we need to use this transformation here to actually bypass this firewall rule. So to do it, it's quite simple. As you might expect, it's just hex encode, which will be 7B. And we will see if this actually transforms into curly brackets. And you can see here in the response that it actually do. Render it, and you can see it's transformed successfully, right? So currently we're in here on the code line. So, or we're actually here, but here our payload will be transformed into this. So if we're sending this one out, we don't need to encode it one more time because it's a B, so it should be allowed, right? Cool. You should be able to do full. Yeah, okay, cool. So we're able to do full here now. If we do this, I think it should be an arrow. Yeah. So we're having an arrow here because Genia did not understand what it should do with our value. So we actually triggered the template injection payload, or the template injection vulnerability rather. If we do 7 multiplied by 7, which is the most common payload, and send it, we get 49. Okay, cool. and we actually bypass the firewall. So this is a proof of concept as well. If the characters are being transformed by the application, the firewall will having an impossible, like it will be impossible for the firewall to detect it, because unless it's actually configured to also check for the different encoding version of the character, then it can block it. Otherwise, you bypass it, right? But it's also an issue that I will go more into detail in other labs if it's allowed different encoding supports. Like if it should support this encoding support, there is a lot of other problematic issues that will happen. But for this one, we bypassed it with simple hex encode, and yeah, that broke the regex, and we're able to execute a template injection. Okay, so we currently did the transformation lab, and we will move on to the next technique. So the next technique is one of my favorite, and that works extremely well with firewalls. It's when you exclude spaces and manipulate spaces in a way that I showed you recently or before in the presentation when I showed you the actual SQL injection. I show you how you could take the simple SQL injection and how you removed every single space within it and combine it with comments and parentheses, and yeah, combine quote, single quote, double quote, cluster it with keywords. So right here are some example of payloads. You might don't know every of them, or you might know all of them, but I just wanted to showcase some of the payloads, like the power of like not using spaces, how many possibilities there are without spaces. So like an XSS, you can do, for example, use /, you can use new lines. For example, right on the right SVG payload on the top right, you can see it's combined with the red double quote combined with unload directly. You can see basically everything that is red marked is replaced or used instead of a space. So what we're going to do now is we're going to send a simple payload like this to the firewall. If we send a payload like this, it will probably get blocked because it's not a super stealth payload, right? So as you saw in the example here before, on the bottom, you can see instead of using spaces, you can use a ton of different things. You can use the variable ifs, or you can use a closing arrow to actually send data from the file directly to cat that will output it. So the payload here, if we take this payload and combine it, or not combine it, which we change it into actual payload like this instead, what will happen when we'll send this to the firewall is that it will getting a lot more difficult for the firewall to understand the actual payload. So in this case, depending on the configured firewall, but in this case it's actually harder for the firewall to see when something within the payload starts a new section. For example, if you had it on the old payload, when you had the space, it's easy for the firewall to see that cat is separated by etc passvd. In this case, when you're having an arrow sign, it might be a bit harder for the firewall to actually see that they are separated. It might think that cats are combined with like the arrow sign and the /, or it's like it's having a harder time to actually understand the payload itself because it's clustered together. So there are also advantages of using spaces. So spaces can be used to bypass the firewall as well. For example, like this. The same scenario, but the opposite will be like, instead of it actually having a hard time to detecting when a new section starts, we will make it think a new section starts. So in image src onload equal on error alert, here we're having a space between the actual equal sign and the alert statement. So we want to confuse the firewall into thinking that on arrow equal is actually an empty value, and actually alert is an attribute that is invalid. That's what we want the firewall to think, right? So this can confuse the firewall and bypass regex, because on arrow can be seen as an attribute with an empty value, for example, as I mentioned, and alert will be a completely new attribute. So we're going through a fast lab on how you can bypass this by using these techniques. Okay, so we will go through this lab here, which is vulnerable to SQL injection. And if we read the description, first of all, we need to bypass this firewall here without using space, tab, or new lines. And we need to extract a flag here, which is within the admin's note. So the users store a note in their database, and the admin's note will be the flag that we want to extract. So the flag will be in the format of flag, and for example, flag 1234. So if we're checking the source code real quick just to confirm the vulnerability, as we always do, we can see our payload is taken from here and it's reflecting directly here. So result, select username, note from users where username equal to guest, and note like payload. So if we do, for example, nothing, it should result in everything, like everything that is true. So we're submitting this, and you can see the result will be here. From the guest has to note just a simple guest user. Okay, so if we do, for example, simple, which is a keyword, it will result in the same because it's checking keywords within this note. So what we want to do here is we want to, for example, write a new statement. So we will do either you can do something false and then you do or, and then you do your select username or note from admin, this kind of stuff. But if you actually check the blacklist here and inspect, or XOR and AND is going to get triggered by the firewall. So if we do, for example, set, and then we do or, first of all, it's triggering the or. And in this regex here, that is another filter, it's actually removing the space, tab, and new lines. So, but first of all, we need to focus on one thing at a time. So we're going to focus on the blacklist. We want to bypass this here. So instead of using or, XOR, and AND, you could use bitwise, which is just a simple pipeline like this. But in this case, it's easier, in my opinion, to actually exploit the already known value that we knew is either false or true. Remember before I told you, if you're inside a where statement, for example, in SQL injection, you could take advantage of this value that you knew. When you escape it, you can do this old value that you escaped from equal to the new statement. So you can make this old value true or false, and then you take your new value that you knew is true or false and combine it with old. I will show you. So if you do, for example, sed, which will be, if we send here, it will be false, no result. If we escape this one and not using any space, we could say this one is equal to 0, and then just comment away the rest, which means sed, which is false because it's no result, should result in 0, which is false. We can do it easy. We can do it like false, like this as well. It doesn't work. It doesn't matter. We're sending it. Oh yeah, okay, it's true because sed is false, so it's false equal false is true. But for example here, you can do 1 to check if this one is actually true. So if sed is true, then it should result in a result, which is to not. It doesn't, right? But before we did false, and because sed was false, we actually check it was false, and that's resulting in true. That's why we got the result here, right? So if we do, for example, 1 equals 1 here, it will be no result because this section here is true and this one is false. But if we remove the sed, we can see we got % signs, which means basically anything. And remember, when we didn't send anything, it was true before, right? So this here on the left will be true, equal to our new value, which will be 1 equals 1, which is true. Submit it, and you can see it works, right? So we bypass the first one by taking advantage of the old. So this is really great because the firewall won't actually be able to see the source code of the vulnerable section on the code. So now we're exploiting the vulnerable section and making the firewall confused and bypass the first step. And the second step here, which will be the regex replace, it's removing all the tab, new lines, and space. Okay, cool. But we're not using it, so we're fine for the moment. So the second or the third protection will be any multi-line comment here will actually be treated as trigger as well. So if you're having a multi comment instead, if you want to, instead of a space which is getting triggered here, you might think of using a multi-line comment like this, but it's also getting triggered, so we can't use it either. But we're already using what we need here. You can see we're using parentheses, right? And remember, as before in the presentation, I showed you can use parentheses instead of spaces for the sleep payload, for example. So in here, if we want to, for example, do select, and we want to do select 1, it will result in true, right? And so this means that if we send this payload right here, it will actually result in true. So now what we want to do, if we want to actually extract the flag, because we've actually bypassed the first blacklist, we bypassed the space scenario, and the multi-comments is no need because we're using parentheses instead. So in here, we're going to select the note. Whoops. We're going to do the note, which you can see here will be within here, the admin, it will have a note. The flag will be inside the note. So select note from, and then inside here, you will have username. We don't need username, do we? No, actually do not, because we're taking all the notes from every user. We just want to actually extract the flag. So sorry, we need first users, of course, we need a table. So, but we don't need actual username because we know the flag format, so we can simply do, like here, we can do where, and then we will have a value. So we will say where note, like, and then in here we'll have our value. So what we're doing here is we're selecting note from users where note having a value, and we can take %. This should be true, right? And it says no. Okay, so first of all we need to check here if this is comparing correctly. We can actually remember before we did 1 equals 1, we can do the same right now, but we're going to do 1 equals here. No result found equal to 0, more than 0. Select note from users where note is note, right? Yeah, and note like anything. If it starts with an F, no. Let's see. This one value is true. If we do it false. Okay, yeah, okay. Gonna have it false here. So when this value is false, it will be equal to something that is, oh, sorry. It's true. 1, okay. Okay, so equal to a new statement over here. We're selecting the note from the users where note like and starting with an F. If this is true, it should result the result. Okay, yeah, it's resulting to the result, and we can see if we do an X, it's giving no result. Okay, so it's true. One of the nodes start with an F, right? So we can try this by just doing the full straight flag right away. And okay, so we confirm. Okay, we got a second injection and we're currently extracting the flag. So I will bypass it because we take advantage of here, taking advantage of the old value, and we're making it to a new statement over here. And I think, to be honest, I think the reason here is because it's different types. Because yeah, it's comparing the types and also the value. So when we did before without this, it's actually comparing this one as a string on the left and this one here as a statement. So now we're extracting the flag. You know, we'll have curly brackets and we can move the % sign in here. That should be true. Cool. And we know it's 4 digits. So if we start with 1, or we can actually do it, okay, it's actually 1. Okay, I was lucky. So it's starting with 1. But if we do double $sign and we add any number here, so 1, we got a result true. So we know it's a 1. I will save it here at the bottom. So we know it contains the digit 1. We're checking 2. No. 3. No. 4. No. 5. Yes. Okay, so we've got a 5. 6. No. 7. No. 8. 8. We got an 8. 9. 0. Okay, so 8 and 9. So we got 1, 5, 8, 9. Some combination of that digits will be the correct flag. So we're gonna try, is it starting with a 1? No. Is it starting with a 5? No. 8? No. 9? Yes. Okay. Is the second digit a 1? No. Is it a 5? No. Then it is an 8. Oh, sorry. 8. Correct. Okay. 5. 1. 5. Yeah, okay, so the last one is a 1. So that one should be the full flag. 9851. We're trying. Okay, cool. So we solved it. So right here to take away is, instead of using OR, AND, or XOR, you can actually take advantage of the old one that bypassed the keywords. Instead of spaces, we're using parentheses, and that works flawless. And yeah, with all this combined, you're having a payload like this, which bypassed the full firewall because it didn't contain any space, it didn't contain any of the keywords, and yeah, it's resulting in successful exploitation and firewall bypass. So now that we took a look at this current lab, which was SQL injection without any spaces, and we also managed to bypass the OR, AND, or XOR statements, we're going to step into the encoding process, which is quite cool actually of thinking about it. And I will tell you why, because it's not as simple as just encoding a payload and it will be decoded on the back end. You can actually use encoding to confuse the firewall in different scenarios, as I will show you here. For example, if you're having a payload like this, you can see the red mark in the payload. It's actually a HTML encoded version of the closing arrow sign. So in this case, if the firewall sees this, it might actually see it like here as a closing image tag, which will result in the green one here actually bypassing the firewall. The reason for this is because the firewall sees an image tag and it also sees a closing of this image. So it thinks that everything that comes after this will be just pure plain text and no actual, not inside a HTML attribute or HTML tag, sorry. So this technique is extremely well, and I bypassed a lot of firewalls with this. Obviously, I combine with other techniques. For example, if you combine this with space, as you can see, this one actually is, because it's using / instead of space at the beginning. So if you check on this one here, this is the different type, or it's obviously a lot more, but these are some of the common that firewalls do attempt to detect. The reason why this is so effective in firewall bypassing is because when you're sending something that we saw here, the arrow that is closing doesn't technically need, like, if it's not decoded in the backend application and the firewall sees it as it should be, like if it sees it as the original value, then it's actually bypassing a firewall, and because it's not decoded in the backend, it's giving no negative effect on the payload, right? So what you can use here is, you can use, for example, like ET, you can use an HTML encoder version, and you can use a URL encoder, for example, if it's not decoding the URL encoded version of it. And you can use it for different vulnerabilities. It's not specific to any, like quotes, for example. If you're inside a SQL injection, you can do a %sign, %27, and confuse the firewall into thinking, okay, now you escaped the SQL, like the SQL statement, but in reality you did not, because the backend did not decode it. So then you're writing a half payload to confuse the firewall, and then you're doing a real single quote, and then you're doing your actual payload. So the firewall will be focusing on the left part, which is just a decoy of your payload. And the other part will actually be the payload that is exploiting the application, but the firewall will not trigger it because it will be confused with the old decoy that you did when you actually encoded the single quote, which was not escaped. So I'm going to show you a quick lab on this one because I think it's really cool on how you can use it and confuse the firewall. So in this lab here, the encoding lab, we will exploit the firewall, or manipulate the firewall rather, into sending an encoded version of a character that is being triggered or handled differently in the firewall detection system than it's actually being handled in the backend. So our goal is to, here as you can see, the firewall supports a range of encodings to detect payload in different forms. We need to bypass the firewall by using a supported encoding that the firewall sees and detects, but the vulnerable application to actually not decode this. So we can see the payload here will be our value inside here. If we're checking here, it's going straight to the actual render section, so it's actually getting reflected directly, and you can see it's using the function onQuote on our payload before it's sending it to the render, or to Ninja to render it on the response here. We can try this out to see onQuote is actually just URL encode, URL decode, sorry. So if we do, for example, tests %22 and then we do X, just to have it more clear, we're sending it, we're checking the source code, and we can confirm it's decoding our quote, as you can see here, and we can also confirm it's vulnerable to an XSS. So what we need to know now is we want to check this firewall and see what is actually blocking us from exploiting this XSS. Checking the blacklist first, inspecting it, we can see, okay, so it's keyword alert confirm prompt console print and throw. Okay, but we're not there yet. We're not actually executing JavaScript yet, so this one is not currently an issue. We're checking the other filter, which is looking like an issue, right? Just as a like a note, you could exploit this if you just do like a simple on a click or autofocus. But if we want to stick to the lab and actually exploit this or use this technique, escape this input is the goal, and then exploit your XSS. It's also having the typed set of text this time, so you can't use the image as we did in the previous lab. So our goal is actually, we're going to make a new tag, HTML tag, and then we're going to do a full XSS payload. So in this section here, you can see it's starting with an arrow sign in %25, %3c, which means if it sees an arrow sign or it sees a %3c or %25 which is URL encoded version, double URL encoded version of the arrow sign, it will be triggered in this regex, and as long as it contains an onload statement, on onload, on arrow, on mouse over, on click, etc. within this tag, then it will be blocked, and it will continue to search for this until it sees a closing arrow sign. So if you do open image and then you do on arrow, it will be triggered until it sees the ending arrow in this URL encoded form or WURL encoded form. So if we now try here with 2522 and see if the application understands it and decode it to a quotation mark, it does not. Okay, so this application do encode URL encode one time, but the firewall do see WURL encoded as malicious as well. So because they are not synchronized, you can actually bypass and confuse the firewall, because the firewall do not know what the backend supports unless you specifically configure it to it. But in this case, it does not. It's triggered on WURL encode as well. And it's very common in real firewall if you think about it, right? The firewall has to be able to see a lot of different payloads. So when you're sending a URL encoded, base64 encoded, HTML encoded, Unicode, hex encode, it has to detect a wide range of these different payloads because it doesn't know what backend supports. So, but it's also a downside because you can use this strategy here, because if the backend do not support it and you're able to smuggle in it within your payload, then you can confuse the regex or the detection process within the firewall to actually bypass it. So what we're going to do here, we're going to simply escape. If we're sending it here, we're escaping. Okay, so we're good to go to write a new tag. We're going to write an image tag, and we're going to test the actual protection, because you always test it to make sure it works. And then you're doing on arrow. Okay, well, we're already blocked. So we're blocked here, as you see. So if I'm sending this one, you can see we're blocked. So this one works, right? But if we're closing this image tag here in between, because it's looking until it sees an ending tag, then it's not blocked. But the payload do not work either, because if we're sending it, you can see we did an image tag and we're just plain text. But the firewall actually supports URL and WRL encode as well. And the application here supports URL encode. So if we will do %3c, free E, sorry, for the closing, it's supported by the firewall, and it's also supported by the backend. So this one did not work. But if we actually do 25, if we can check the regex one more time, you can see it supports 25 free C. This one should be treated the same as all the ones we previously did within the firewall, but not in the backend. So we're sending this one, and we can see free C. So this one did not decode. So now all we have to do is adding a source here, and on arrow here should actually not be triggered anymore, as you can see, because the firewall thinks this one here is an ending arrow sign. So now we just want to bypass these blacklists, which is alert confirm prompt console. And you can do it because it's JavaScript. JavaScript is JavaScript. So instead of doing alerts, you can still do alerts, right? If you didn't know, you can do straight Unicode within JavaScript. So if you do \u for your Unicode, and then you just do the value of a small a or a lowercase a, this will be an a, and this will be alert. So alerts, then we will have the parentheses, and then we do 1. And to see the execution, you do the I, and boom, we're able to solve the lab by using the confusion. So the confusion here is that it thinks the image itself is already closed, so the firewall thinks that everything that comes outside or after this encoded closing arrow sign will be treated as just normal pure plain text. But in reality, because the backend do not actually decode it, it will still be inside the image tag, and it will just be an invalid attribute, and the SRC will be an invalid source. So when it's getting on, when you trigger an arrow, you're just setting on an arrow, and then you're setting your payload. And because JavaScript is as it is, you can just use pure Unicode to bypass the blacklist. All right, so we just finished the last lab, which was the encoding, and together with this, we have done all this lab now with excluding spaces, we have done with encoding, we're done with filter collision, we're done with transformation, and all these techniques here that we learned are extremely useful in modern web applications, especially when you combine them and make them more advanced. Each lab have contained specifically focused on its sections, but in real world you can use one technique all up to all of them to combine your payload and to make your payload extremely stealth, right? So as a conclusion of the full presentation, we have learned to understand a firewall's blind spots, where the firewall having a hard time to understand, where it's actually a malicious part and where it's not a malicious part by using these strategies. We have then mastering a new methodology when instead of sending full payloads, like fuzzing for payloads and bypassing, you can take one payload, send a full payload. If you get blocked, you then splitting the payload into different parts, sending one part and see if that part actually is the trigger of the actual full payload. Setting up a theoretical scenario and then remaking your payload as we did with the sleep 4 in the SQL injection. taking the prefix, which was the single quote or parenthesis, and trying to see if this is the actual first trigger of the firewall. If it is, then you modify it and remodify it until you actually bypass the first step of the firewall and continues to the full payload is done. Well, understand different techniques, which is the filter collision, transformation, encoding, and also excluding spaces from your payload. And combining this, I can assure you that you will bypass a lot of modern firewall configuration out there. And of course, you have now learned how you can use everything that I just mentioned to create your full own payloads. And I highly recommend you actually use techniques like this. You can take payloads like that is already done, but you modify them and customize them and make an own word list with payloads and detection payloads to actually use them yourself, because you're now having the skills to make your own payloads more advanced, more stealth, and get under the radar and detect vulnerabilities without getting false positive or blocked. So with all this said, I want to say thank you, and yeah, thanks for listening to my presentation.
All right. What an amazing and impressive presentation by Alex. Big thank you to him for being a part of this year's conference and hosting these labs. So if you actually wanted to play around with the labs, go to the link right here. It is posted right here. I'm going to try and point properly right there. There we go. It's posted down there. You can actually play around with them. I know they have a lot of more different labs. So if you want to do IDORs, SSRF, I'm looking at the website right now. There's IDOR, SSRF, all these different ones, you can actually go on there and do them for yourself. All right. How are we feeling, everybody? How's it going? How's everyone doing? Are we still hanging in there? Who's in the chat? I want to see who's still hanging out. I know there's a good number of you guys still watching, a large number of you guys, but for everybody asking the question about workshops, most of them will be available. We're still trying to figure out the format which we want to keep these in. At some point, either today, tomorrow, or Monday, we may just release everything all at once. We just don't know when yet, but most of these will be available later. All right, let's see. Everyone's still here. Nice. Very cool. All right, we're going to take a quick 5-minute break. Tiberius is coming on next, and he's actually going to do everything live. So his presentation is live. He's going to be interacting with you guys. He's going to be doing some SQL stuff. And I don't call it SQL because I know he doesn't like me saying SQL. So if he's here listening, we're going to have him do SQL injection. Just a reminder, today is the workshop day. We still have day 2 tomorrow where all of our talks happen. So we're going to have people like Shubs, Zishano, Tom Nom Nom, Jason Haddix, Godfather Orwa, Rezo, Lupin, everybody. If I'm missing anybody, I'm sorry. But also Justin and Joel from the podcast, the Bug Bounty podcast, will also be here, and they will also be hosting the conference. So it won't be me solo, it'll be with them as well. But with that said, I'm going to remove the banner at the bottom. So if you want to go and check them out, go down here to the website. It's going to be removed in the next couple of seconds. But we're going to take a quick break and we'll be back in 5 minutes, maybe less than 5 minutes with Tiberius. All right. I think it is time to bring on our last speaker for today. Chat, let me know if you're still here. I'm going to bring on Tibbs really quickly on here. Tiberius is going to be talking about what I call SQL injection, but he likes to call it SQL. But we're bringing him on stage really quickly. How's it going, man?
I'm leaving. You
Yeah.
mispronounced it too many times.
Don't leave us just yet. We're gonna need you to go through your workshop, and I know a lot of people are excited about your workshop, including myself. I am actually
Excellent.
garbage at SQL injection, as you put it. So I'm really, really excited to learn from you, man. I'm gonna remove myself, and the stage is yours.
Awesome. All right. Hello, everybody. Hopefully you can hear me okay. Let me know if my mic is, I don't know, too quiet or whatever. All right. Let me start this slide. So I got a quick slideshow. This obviously is live. But we'll get through a little slideshow at the beginning, and then we'll get onto the actual fun stuff. Okay, so let me just make sure we can. Perfect. All right, that looks good. Let me just minimize a few things so I can actually see chat. Volume is good. All right, that's excellent. Okay, so this is SQL injection tips and tricks. I am Tiberius. We'll get the first boring slide out the way. I'm a web app pen tester. I've been a web app pen tester for about 12 years now. I'm also a cybersecurity content creator on YouTube and Twitch. And I'm an educator in all things web security related, basically. I'm on too many social networks, so there's a link tree on the screen right now, linktree/Tiberius. You can follow me on whatever your favorite social networks are. All right, but let's get into it. So first things first, today's labs, we're going to be using Portswigger Web Academy. There's the link on the screen. This is free, but it does require an account. Okay, just FYI. So if you want to do the labs with me, or you just want to experiment with the labs during this workshop, please go to that link and sign up for an account. Again, it is free. You just have to log in. All right, but these are the labs that we'll be going through today. It's Portswigger Web Academy. If you're really interested in anything to do with web security, they're such a good resource, especially considering you don't pay anything. Okay, so I'm assuming if you show up to a workshop on SQL injection tips and tricks, you already kind of know what SQL injection is all about. But let's just go over it very briefly. So in a web application, you would have, for example, a username input and a password input. And let's just say the username input is set to admin and the password input is set to let me in. And these values could be placed directly into an SQL statement. All right. So in this case, the statement is select ID, status from users where username equals admin, and the admin is the username input, and password equals let me in, and that's the password input. And what does this do? This finds rows in the users table where the value of the username column is equal to admin and the value of the password column is equal to let me in, and then it returns the ID and status column values for those rows. Okay, pretty simple. So here's where the SQL injection gets interesting. So now what we've done is we've changed the username input. So we still have admin, but after that, we've put a single quote, and then we have this dash dash and a space and then a dash. And that's basically an SQL comment. All right, you don't need to worry about that right now. But we've also changed the password input just to make sure that we're using the absolute wrong password. The password input is now wrong pass. And so what it's done to the SQL statement, we still have the select ID status from users where username equals. But now what's interesting, right, is the single quote from our input is kind of matched with the single quote that was originally part of the statement, all right? And so now realistically, we're still actually saying where username equals admin, all right? Because this single quote matches with this one to form the string admin. And then this is just an SQL comment, which means everything from this point onwards is going to be commented out. So what does that actually mean? That means that the actual SQL executed on the server is this. select ID status from users where username equals admin, and then everything that is currently shaded out gray does not get executed. The SQL server does not consider this part of the statement anymore. It just considers it a comment. Oh, so what does it do? Well, it finds rows in the user's table as before, where the value of the username column is equal to admin. All right, but again, the password check does not happen. It still returns the ID and status column values for these rows. Okay. So let's talk about SQL comments. Most SQL database variants support this double dash space comment. Okay, so you have these 2 dashes, a space, and then this is all commented out. All right, that's the comment. You got to note this is really important, and this is one of the tips. A space is actually required. Okay, so if you just have a double dash and you leave that space out, this is technically not a comment. This is now a syntax error. Okay, so that's really important to know, that you have to have this space. And this is why I recommend using this double dash space dash. All right, so basically this ensures that we remember the space is right there. You just get into the habit of putting that space in and then the extra dash. This realistically can be anything. All right, it doesn't have to be a dash. I just use a dash because I've just typed 2, right? But this is all commented out now. So why do we do this? Well, other than just it being a nice way to remember it, you got to consider this following pseudocode. All right. So in the first line, what we're doing is we have a username variable, and we're getting the user input. So we're getting basically the username that the user has typed. All right, and setting it to this username variable, and then we're calling this strip function or method or whatever you want to call it on the username variable. And what this strip function does, it removes leading and trailing white space. Okay. And then finally, we're putting the username variable directly into an SQL statement. All right, we're surrounding it with single quotes, putting the username variable there, and sending that to the database. So what happens if we just use a double dash space? All right, so we have a username input admin, single quote for the injection, and then just 2 dashes and a space. What's going to happen to this when we set it to the username variable? Well, that strip function is going to remove that last space. So now we just have a double dash. Okay. And so when it goes into the SQL statement here, we got select all from users where username equals admin. That's fine. But then we have this comment followed immediately by a single quote. And remember, this is a syntax error. So this is not going to work. So an extra dash or any non-white space character, basically, as long as it's not white space, this will avoid the issue. So here we have the username input admin, single quote, double dash, space dash. When it goes to the username variable, again, it's still passed through that strip function, but because there's no white space on the end, the double dash, space dash is still preserved. And we actually get a comment right at the end here. So that's really important to know. I would honestly get into the habit of using, if you're going to use double dash as the comment, use a double dash space and then an extra dash on the end. So in some cases, we don't actually want comments, all right? So this SQL query, we've got select all from users where username equals admin and important column equals some unknown value, all right? Let's just assume this is all hard-coded, but this is important, all right? For whatever reason, the database, when we're doing the application, when it's selecting this data, it needs important column to equal to some username, some unknown value, all right? So if we use this username input again with the double dash space dash, what happens is now we've commented out this really important part of the conditional, okay? Now, we still get a result, okay? Because this is a valid SQL statement still. We haven't made this SQL statement invalid, but the application might handle it differently, and that's because the important column constraint was just effectively removed by our comment, all right? And we don't know this happened, right? Because ultimately, we don't really get to see the SQL on the server, all right? We just know that we commented out everything that followed it. So sometimes we don't want comments. So what we can do instead, remember, basically what we're doing with SQL injection here is we're breaking out of this string. So what we can do is just break back into the string. All right. So now what we do is we have a username input where we have admin, the single quote to break out of that string, and then we just do an and 1 equals 1. Okay. And you'll note there that this final one does not have a matching single quote around it. That's because that single quote already exists over here. So basically, the SQL looks like this now. We have select all from users where username equals admin and 1 equals 1. Again, this single quote is now matching this one instead of this one, and everything is perfectly balanced. So both queries are practically identical, right, despite the injection happening, because an and 1 equals 1 is effectively just saying and true, right? That doesn't change anything about the statement itself. For all intents and purposes, you can pretty much just ignore that and 1 equals 1. But what this actually does as well, it's really useful because this allows us to use some Boolean logic to confirm the injection and extract data. Okay, so because we have this and 1 equals 1 here now, we can change that to and 1 equals 2, which we know is always false, and see what the response contains. And that allows us to differentiate between a false and true statement on the database server. So another really good tip that I have is try to always initially use at least what I call valid values. A valid value is an input which produces a positive, repeatable result in the application. Okay, so for example, if we have a product system and we have an ID equals 1, that displays the product with ID equal 1, right? So the database takes that ID value of 1, looks it up in the products table. If it exists, it displays the product, right? And because there is a product with ID 1 in the database, it's going to display that product every single time. So that's a valid value. 0 is usually an invalid value. All right, doesn't have to be. Obviously, some people really like counting from 0, especially if they're programmers. But more often than not, ID of 0 is invalid. And let's just say in this case it is, and it displays a 404 page because there is no product with ID 0 existing in the database. Another potential value you could use is -1. All right, if you're doing values, if you're doing integers, for example, negative integers for IDs are often quite useful as well. And this is actually quite important because with no other indicator, like a visible error message, right, with SQL query syntax in it, or even just stack traces, it's actually easier to find SQL injections when you use a valid initial value than it is when using a valid one, an invalid one. And let me just explain that for a second. So let's consider we have a search function that returns a 200 OK for valid terms. All right, but a 404 not found for invalid terms. And let's just say, for sake of argument, if the SQL query fails at any point, it also defaults to a 404 not found. And that's because there's some logic in the application that says, well, if the SQL query returned nothing or returned no rows, then that's a 404. All right, it doesn't care that there was an error. It just cares about the data that was returned. And in the case of an error, obviously, no data is ever going to be returned. All right, so what we have here is this table with 3 columns. The first column is going to be our input. The second column is going to be the result in a vulnerable app, basically an app that is vulnerable to SQL injection in this particular field. And the third column is the result in a secure app, all right? So an application which does not have this SQL injection. So if we use a valid search term, which is just going to be valid search term, we get a 200 OK in the vulnerable app and a 200 OK in the secure app. And that's reasonable. All right. It's a valid search term in both. OK, there's no SQL injection going on. We would expect a 200 OK. So now let's do a basic SQL injection and just put a single quote. All right. So now we have the same result again, but for 2 different reasons. In the vulnerable app, we get a 404 not found. Not because it's now an invalid search term, but because the SQL query failed. Our single quote caused an error, which propagated through, returned no results, and so the vulnerable app displays a 404 not found. The secure app displays a 404 not found because our valid search term is now technically invalid. All right, it's got a single quote that's invalid. So now what happens if we do a standard SQL sort of repair by putting a comment there, right? So we're injecting and we're also commenting out the rest of the query in hopes that we can get some good result. In a vulnerable app, we get a 200 OK again. And that's because technically speaking, according to the SQL syntax, right, what our valid search term is still just valid search term. All right, it's this string. It doesn't matter that this is all commented out. All right, we ended the string here. So for the vulnerable app, it thinks basically we're still searching for just valid search term. So the result is going to be the same as if we were just searching valid search term alone. Now, in a secure app, we still get a 404 not found, and that's because there is no SQL injection, and this is still invalid. All right, but you can see there's a difference here. We go from 200 OK to 404 not found back to 200 OK. Now, let's consider what happens if we start from an invalid search term. Well, if we start from an invalid search term, we get a 404 not found in the vulnerable app because it's an invalid search term, and likewise, same in the secure app. Now, if we try an SQL injection, we get a 404 not found, but it's for a different reason, right? It's because it's the same reason up here. We get a 404 not found because we're causing the SQL query to fail. All right. And in the secure app, it's literally because it's still an invalid search term. And then when we repair this query and we comment out the rest and make sure this is a valid SQL statement again, we still got a 404 not found, this time again because it's invalid search term. But the issue here is there's no way of differentiating between whether this is a secure app and a vulnerable app when you use an invalid search term, because effectively the same thing is happening in both applications. Whereas before, because we used a valid search term, all right, even though we had 200 OK on both sides for this and 404 not found here, it was this row, right, this final search term we used that confirmed our SQL injection. All right, so that's really important. Always try to initially use these valid values because they're so much more useful. And unfortunately, it's really annoying. In bug bounty, sometimes you don't get valid, you can't find valid search terms. If you're pen testing, you can always ask the customer for a valid search term or any kind of valid value for some kind of input. That's really useful. In bug bounty, it's a little more tricky. All right, but if you can, try to use valid values. That's not to say that invalid values are useless. They are actually pretty useful. You should always switch to invalid values when they're needed. So let's consider if application code only cares about the first row of results returned. All right, so in this case, let's say we have this product select. We're selecting the name and the price from products where the ID equals 1. Okay, and our input, we're just going to do a regular union injection. All right, so our input, this 1 is obviously just going to match this ID here. We're unioning and we're selecting. We need 2 columns because when you're unioning, you need to match the columns. We're going to select a string, just str, and we're going to select a number like an integer, right? So 1 through 37, and we're just going to comment everything out. So the SQL statement that gets executed is this one. Again, this is valid, but we're selecting name and price from products where the ID equals 1. We're unioning it with a select string 1337, and what happens is we get this table generated. So this half of the union, the select name price from products where ID equals 1, returns jacket and 4499, all right, because the jacket just happens to be the product with the ID equal to 1. And then this select string 1337 forms this part of the table, okay? But because the application code is only going to care about the first row of results, all right, because it's expecting 1 product when you give an ID of 1, only the first row is going to be read by the application code, right, despite our injection creating another. And so this can actually happen with union injections where you're injecting into a page that only displays 1 of those rows, and it's the first row it's going to display. Okay. So what we can do, if in a union operation, if the left side of a union returns no rows, then logically, the first row of the result is going to be the first row of the right side of the union. So what we can do is we can choose an invalid value for the ID, e.g. a 0 or a -1. So instead of a 1, we put a 0 here. Again, everything's going to be the same. And now this left side of the union is going to return no rows because there isn't an ID, there isn't a product in the database with an ID equal to 0. But this right side of the union is still going to return string and 1337. And so that's what we get. And now this is the first row. And so on the product page, what we'd expect is it to show our str value here as the name of a product and the price here. Okay, so let's talk about simple SQL injection and what I call the break and repair method. And I've been sort of talking about breaking and repairing throughout the presentation. Let's actually dive into that a little bit. So this is my methodology for finding, manually finding SQL injections, and it's pretty reliable. The first thing when you're searching for SQL injection is obviously you have to identify potential SQL injection entry points, and those usually come in forms of parameter values, right? Whether it's in the URL or the body, sometimes even cookie values. Then I find both valid and invalid values for each entry point, and I note the responses for each, okay? Usually what you would hope is that the valid and invalid responses are going to be you're going to be able to differentiate between what counts as a valid and an invalid response. We then attempt to break the SQL, all right, by appending either a single quote or a double quote to the valid value. All right, no, it's the valid value we're using. And again, 99% of the time, it's going to be a single quote. All right, you can technically use double quotes in several databases, but most of the time, most of the time, it's going to be a single quote. And then if the response changes, which we would expect, all right, because we're breaking the SQL in some way, we can then attempt to repair the break. And we repair it not by, obviously, we could repair it by just, removing the character, but that doesn't really help us. What we want to do is we want to repair the break by adding additional characters. And then if our repair results in the original response, right, the original valid response, or at least a different response to the broken one, then we may have some SQL injection. Not always, but it's very likely. So here's a list of generic repairs, and this is assuming that we've injected a single quote. So if we inject a single quote, one repair we could do is just put a space and then another single quote. One repair we can do, assuming this is our single quote, is we can do 2 pipe characters and another single quote. I'll explain these in a minute. We'll go over them first. Another repair, assuming this is our single quote, is we just put a plus symbol in a single quote. Now, this is important. Remember that in the URL, a plus is a URL encoded space. So if you're dealing with this in the URL, you should definitely encode this to %2b. Okay. We could do something more complicated here. So this is our single quote or initial break. We could put an and then we could inject back into the string, right, with a 1 = 1. Remember, don't put the dangling single quote here because we're assuming it's already in the SQL quote. And finally, we could use our single quote and then just append a comment. And again, we've got to remember, we're appending these values to the original valid value, all right? So if our valid value was the word valid, right, and we used a single quote to break it, then let's say we select this one as our repair, you append it to the original valid value. You don't append it to the valid value with a single quote, right? So it wouldn't be valid single quote, space, single quote, all right? You're appending the repair to the original valid value. So the first 3 are actually different ways that SQL servers can concatenate strings. And by concatenating a valid value with an empty string, right, I hope everyone understands that that means the value should remain the same, okay? If you take the word admin and you concatenate it with an empty string, you just get the word admin back. And because we already know the word admin is valid, right, if we concatenate admin with an empty string, that should also be valid. So the following statements are practically identical in certain database servers. So here we have select all from users where username equals admin. This is the default case. Okay, there's no injection going on here. This works on all databases, clearly. Okay. But where we select all from users where username equals admin, and then we have a space and then 2 single quotes. All right. So remember this bit here is our repair. This works on MySQL. In MySQL, for some bizarre reason, I don't know quite why, but if you have 2 strings separated by a space, it will just concatenate them. All right. And in Postgres, SQLite, and Oracle, if you have the 2 pipe symbols between 2 strings, they get concatenated. And then in MS SQL or SQL Server, right, Microsoft's version, if you put a plus character between a string and an empty string, they get concatenated. Okay, so those are all practically identical. They all should return the same result in whatever database is listed here. So concatenation repairs are more useful because they give us clues about the database variant, right? So clearly, if this works, if this one works, we're pretty certain it's MySQL or at least a derivative of MySQL. Okay, so MariaDB, for example, is basically a fork of MySQL. It does this, but it's effectively the same thing. Okay, if this repair works, then we know it's one of these. Unfortunately, it's not as concrete as MySQL, but we know it's one of these 3 or a derivative of one of those 3. And if we have a plus work, we can be pretty certain that it's MS SQL. Okay, so the concatenation repairs give us clues about the database variant. The final 2 repairs, though, right, they can still be useful when it comes to exploitation. Again, we've gone over this because the and 1 equals 1 can be used for Boolean logic. We can change one of these 1s to a 2 or a 0 or any other number, basically. And we can use that to determine what a true and false statement looks like in the database. And this second one, this is useful if we really, really do want to bypass any following conditions. This is definitely effective when for login bypasses, for example. So these final 2 repairs, they're good to use sometimes. They don't really tell us anything about the actual database itself, but they do have their uses. Just going to have a drink very quickly. All right, so in some cases, none of our repairs may work. All right, and that's because we're injecting into an integer value. All right, so for example, if our input was 1, like in the sense where you have the products where ID equals 1, if we try to use this repair, like for example, if we just use the single quote, that's definitely going to break the SQL because a single quote doesn't belong here. It'll give a syntax error. Okay, but if we try to repair this statement, we're still getting a syntax error, right? This is still technically invalid because we just have this dangling single quote here. We were assuming it was being treated as a string, but in fact, it was actually being treated as a number. I'm going to turn off. I'm going to turn off Steam. Hang on. Let's exit Steam for now. Yes, I play CS2. All right. Okay. So, in these cases, we can try the following repairs, and there's really no good way of showing this without this. So basically, you'll see what I mean in a minute. But if you see this red like rectangle, this is just a placeholder for a literal space. All right. So if I didn't have this there, it would just look like a double dash space dash. All right. But you need a space here usually. That's usually that's pretty common. All right. So put the space there. The second one, again, we have spaces on either side, just to and 1 equals 1. So these look very, very similar, right, to the original repairs. We just have taken the single quote out. All right, and finally, we have this one again. So we can do an and 1 equals 1 with a comment at the end of it. All right, let's talk about identifying variants. All right, so You can sometimes identify variants using using these repairs, like we said, especially with MySQL and MS SQL. But we can actually do one better. So there are 5 common database variants. All right, we've got MySQL, Postgres, MS SQL or SQL Server, Oracle, and SQLi. Each database variant has unique operators. All right, so even though they all use the same kind of SQL structure, there are operators and functions that are unique to each of these database variants. And this is really useful because these cause errors when used on the others, all right? So imagine that you're coding in Python and you try to use a function, all right, that's in PHP, for example. All right, Python is going to complain because it has no idea what you're trying to do. If it's a PHP only function, you just can't use it in Python, right? And the same goes here. If you try and use a Postgres-specific function in MySQL, MySQL is going to complain about it. So here's the theory, and this is a theory that I've kind of come up with, and it doesn't work all the time, but it's pretty reliable. With the correct order, all right, of operations, we can actually create a list of test payloads which will identify the database variant we're injecting into. Okay, and let's see how that happens. This is an order that I use. Okay, so it's very important you have to go through it in order because some of these functions are in multiple variants. All right, but by going down this list one by one, we can actually effectively exclude several of the later variants earlier. All right, we don't even have to get to these. So the obvious one is if you can inject this statement, all right, we know that MySQL is the only database variant that I know of, all right, where a space is a concatenator. Okay, and so if we can inject this and foo space bar equals foo bar, and that returns a valid response, right, one that we know is valid, we can be pretty sure that we're using MySQL. Okay, but if that doesn't work, then we just move on to the next one. And in this one, what we're doing is injecting this data length function. Data length function, as far as I can tell, is pretty unique to MS SQL. All right, and we give it a string of 3 characters, and it will return the number 3. So we do the comparison. If that produces a valid response, all right, then we're pretty sure this is MS SQL. If both of these fail, all right, we can go on to this one. We can use the to_hex function, give it a 1. Remember, this has to be a numeric one. You can't surround this by single quotes. But you can also compare this to a single quote. And if this works, we know we're in Postgres. All right, if not, length B, this is technically length byte, I think. Yeah, byte length, I think. So length of byte foo should equal 3. Again, if you have multi-byte characters, it won't equal 3. So this is, this is why this is important. But foo, each of these characters is 1 byte. And so there are technically 3 bytes here. We compare it to number 3. That should produce a true response. And we can be pretty sure that's Oracle. And finally, if we really want to double check for SQLi, we can use the glob function. Okay, and in this case, it's not really regex. It's basically just a wildcard feature. All right, so we're basically saying, hey, does the wildcard foo with an asterisk match foobar? And yes, it does, because an asterisk can stand for anything. And so we just do an equals 1 here. Okay, and if that works, we pretty much know it's SQLi. Oracle, is it 3 or 3? It can be actually either. I think in both of these instances, it can be either, which is really useful. So this process does have its limits, all right? If everyone's screenshotting this, you don't need to. I'll reveal all in a minute, but this process does have its limits. For manual enumeration, it is still quite reliable. In practice, you should probably use automation like SQL map, right? That's much better, generally speaking. SQL map also supports far more than just 5 variants here. So it supports some of the less common variants, but these are pretty good. Okay, so let's actually just see how this would work. All right, let's just do a random walkthrough. So let's say we've determined that the admin input is a valid value, and that returns a 200 in the status code of the page, right? And then an invalid value, like no such user, returns a 404. So we do our basic injection. We put a single quote, and we get a 400, all right, a bad request. And via a repair, we double check, we repair this statement. We know that injecting an and 1 equals 1 like this gets us back to the original valid value. Okay, so now we can start testing. And the first thing we do is we test, hey, well, if we inject this and foo space bar and it's equal to foo bar, does that give us a 200? No. That gives us a 400, all right, which means that it's caused some kind of weird error on the database. That rules out MySQL. Okay, so now we move on to data length. Again, we have to go in order. So the next one is data length foo equals 3. That also produces a 400, so that rules out MSSQL. And now we're going to and 2 hex 1 equals 1. That produces a 200. That's great. 200 is exactly what we wanted to see, right? Because it was right here. And so that confirms that we're using Postgres. And so because we've confirmed Postgres, we don't need to test for Oracle and SQLi. That's the beauty of this method. As soon as you get a positive result, you can stop. All right. So we've got a few resources before we actually go on to the lab stuff, and hopefully you've all signed up. So the first is DB Fiddle. SQL Fiddle used to be quite good. Now they've got rid of Oracle, which is really annoying. dbfiddle.uk is an amazing site. So it supports, I think, 10 database variants. You can use it completely unauthenticated. If you click on the database variant you want to use, like, for example, you could click on Oracle, it will bring you to a page where it gives you access to just a generic Oracle database. You can then execute multiple queries. You can load a like a sample database with actual like dummy data in it to experiment with. But DB Fiddle is amazing. And if you do any kind of SQL injection, you should be using DB Fiddle because you can visualize what's happening. You can sort of experiment. If you type in a query that you think is being executed, you can just play around with it and see, hey, what's my injection actually doing? Is it causing any weird errors? All right. So DB Fiddle is awesome. Portswigger Web Academy, again, this is the lab that we're using. They have an SQL injection cheat sheet, which is, again, pretty good. All right. And this is new for NahamCon. All right. I have released my own cheat sheet. Okay. This is the result of several years of work, and I will keep updating this. But this cheat sheet is going to contain all the information that we've talked about today, at least in an easy digestible form. It's also going to tell you how to extract various types of information from databases, and we will look at it shortly. Actually, we'll look at it right now. Okay, so tiberius.com/SQLi. So if you go here, let me zoom in a little bit. So again, I'll probably improve all these, but we have the break and repair method here. Okay, so explaining it. We have the identifying variants. And then we go down. These are all the ways you can do comments. So MySQL has 3 ways. Basically, it has this hash. All the others, you can use a dash followed by the comment, or you can use these inline comments. Concatenation. Here are all the different ways to concatenate. You can use the concat function in every single database, but here are different ways of concatenation. Here's how you do substrings. All right, so start and length, right? Here's how you get the length of various strings. And it's important to note in some databases like MySQL, the length function counts the number of bytes, but the char length counts the number of characters, including multi-byte characters. Okay, so whereas length, if you give it a multi-byte character, right, a single multi-byte character might actually have a length of 3, even though it looks like it should have a length of 1, right? Char length will give you a 1, all right? And that's the same for MSSQL has these 2. Oracle has length B for counting bytes and regular length for counting characters. Group concatenation. We can go on that. We can go into that a bit later when we're dealing with some of this. Converting characters to integers for comparisons. This is really useful for blind SQL injections. All right, because usually you wanna enumerate where a character falls, and sometimes you can't just compare characters. You can't say, well, is A less than B? All right. Sometimes that doesn't work, but what you can do is you can convert the character to hex and do a comparison. Okay. Or you can convert it to just its regular ASCII code and do comparisons with integers. Here are all the ways you can limit and offset queries in all the different databases. Note there are different ways depending on the version of Oracle. Ways of getting the version information out, the current database, listing databases, listing tables, listing columns, some various different types of exploitation using Boolean errors, error-based injection payloads. There are a lot of these, so we may be able to get into these later, depending on how well the labs go. But all different payloads for using for generating errors in the SQL, which return information in the error messages themselves. Time-based payloads, both simple and complex. Okay, so we'll be keeping this open as we go through the labs. All right, so the first lab we're going to go to, hopefully, if everyone wants to follow along, I've got Burp Suite open. We're going to be using Burp Suite. We're not going to be using Intruder, though. We're going to be using Turbo Intruder later when we do blind stuff. So even though I'm using Burp Suite Pro, we're not actually going to use any of the Pro features, okay? So the first thing we want to do is the login bypass. So the way that we do this, generally you load the lab up, you can read the lab, it contains an SQL injection vulnerability in the login function. To solve the lab, perform an SQL injection attack that logs into the application as the administrator user. And then what you do here is you click, so I tend to right click and open a new tab, just so I have this on display here. And if there are any questions as you go along, please ask them in chat. I can see the comments. So I can hopefully respond. All right, so what I'm going to do is I'm going to copy this URL now. I'm going to go to Burp, open the browser, paste it in. Perfect, okay. So now, if I click my account, we can just type test and test. Invalid username or password. If we go to the history, great. Okay, so we see this post request to login. If I send it to repeater. All right, now we actually know a valid value here. All right, because they told us that the administrator user is a valid value. So let's change this to administrator. Okay. And so this we know is technically valid, right? The username is valid. The password clearly is not. All right, so what happens if we just try a basic injection here? We get internal server error. Excellent. So, you know, we could try a simple bypass. All right, but why don't we try and figure out at least what the database is what type of database we're dealing with here. All right, so what we could do is we could put a space, and remember a plus is technically a space when it's in a URL encoded position like this. So what we can do is this. We get an internal server error. Okay, let's replace that with 2 pipe characters. And there we go. All right, so we've actually repaired this statement. So we know this is very likely to be either Postgres, Oracle, or SQLi. All right. We could technically go further, but given that we just need to bypass the login, there's actually an easier way. So what we could do here is literally just put double dash space dash, right? And all that's going to do, if you imagine the SQL query maybe looks a bit like this, select all from users where username equals administrator, and password equals, and then we don't know this bit, so don't know. All right, we don't know this bit. All right, so if we want to bypass this, realistically, without knowing the password, we have to comment this bit out. Yeah. Okay, so by commenting it out, by doing a single quote and then putting our comment in, effectively what this is going to do, it's going to render this bit useless. All right, and so all we're going to do is select all rows from the users table where the username is administrator. That should be 1 row. So let's try that. So I'm going to do administrator. And we can just put anything in here. I'm just going to spam some stuff. And there we go. Okay. So let's log out again, because what happens if we don't know a valid value for this? Okay, sometimes there are instances. All right. Now, if we don't know a valid value, we have to use that nasty little injection that you know I hate doing. All right, because if we don't know the username, all right, so we could just put anything here, test. All right. We still have to bypass the password requirement, but even if we did an injection like this, right, and we basically commented out all of this password requirement, there is no username test. So it's still going to return no rows. And so in this case, what you have to do here, yeah, exactly. We have to unfortunately use an or 1 equals 1. But obviously an or 1 equals 1 is dangerous, okay, because an or 1 equals 1 doesn't just return one row, it returns all rows. So what we can do is we can be a little more sensible at least, all right? Because we know we only want one row, all right? So what we can do instead is do or 1 equals 1, limit 1. All right, we're basically telling the database, hey, we want basically any rows where the username equals test, which we know is nothing, right? No rows, or where 1 equals 1. So that's going to return all rows. We're just going to take the first row. All right. And so what we can do here is we can just do, let's just do test, for example, or 1 equals 1, limit 1, and then put the comment in. And we get logged in as the administrator. Okay. Does that make sense to everybody? Are there any questions? Now is the time for questions if you have any. If you don't know why I try and avoid or 1 equals 1, I have a whole video on it. If you Google for it, I've spoken at length about it. What is the text box used with parameters? It's still the same. All right, so it still ultimately gets placed like this into a request. All right, it'll just potentially have new lines, but you don't need new lines to exploit this stuff. How to protect against this? Generally speaking, with SQL injection, what you want to do is use prepared statements. Is there a way to select the? That's actually good. Yes, there is. So how do we select the second row? Well, let's go to. Here we go. So we know we're probably in either Postgres or Oracle or SQLi. So luckily, I think let's just try it. We'll assume we're in Postgres. So if we want to limit to one row, but starting at row 5, we would do limit 1 offset 4. So let's say we want to start at row 2, all right? Because just by limiting 1, we start at row 1. So if we want to start at row 2, well, if we want to start at row 5, we do an offset of 4. So we need to limit 1 offset 1, right? Because whatever row we want, we subtract 1 from. We want row 2, we need to offset by 2. So I don't know if this is actually going to work. I don't know how many users are actually configured in this database. So this will be an interesting experiment. But that was a good thought. So let's just do limit 1 offset 1. This should return. There we go. The wiener user. All right. Test or 1 equals 1. Limit 1 offset 2. So this probably Carlos, maybe? No. Okay, so there's only 2. Sometimes so usually in these, there are either 2 or 3 users. Administrator and wiener are the 2 default users. There sometimes are Carlos. Do you have can we bypass prepared statements? Not usually. So there aren't technically injections that bypass prepared statements. There are weird things with you can do sort of weird wildcard denial of service attacks. through prepared statements sometimes, but that's quite rare. Do you have a preferred method for identifying number of columns to be returned? Do you fuzz them through? No. I use order by, generally speaking. We'll actually get onto that, and I think that's the next lab. It's going to be the union lab, so we'll see that in a minute. Are there bad use cases for prepared statements? Can they mess it up somehow? Not generally, but there can be instances where, so what you can't do with most prepared statements, if for whatever reason you want users to control the columns, right? So, for example, let's just say ID, username, password or something, right? So in most cases, user input is going to be placed after a where, right? So it's going to be placed here somewhere. That can sometimes be when in a comparison with a column name, or it can be order by like a column name here, like order by username, right? Or it could even be like, sometimes you see like order bys where you can inject into the ASC, the ascending operator, right? So most injections occur after a where. However, there are some instances I've seen in the past where where developers want users for whatever reason to be able to control which columns are selected. And unfortunately, with prepared statements, I think most prepared statements don't support columns like that. So that could potentially be an issue. How to fetch the password? So in this case, you can definitely do it. It's tricky, though. I will say that. It's basically a blind SQL injection. We'll do blind in a minute. But you can technically extract information from this. It just takes a while. And also SQL map, strangely, not very good at finding blind SQL injections in logins. There is a way to do it. It requires messing around with SQL map a lot. So it's kind of annoying, but all right. So the next thing we're going to do, we're going to close these down. So we're going to go to the union attack, retrieving data from other tables, all right? SQL injection union attack, retrieving data from other tables. Do these queries show up in the HTTP logs? Like, kind of blue team see which exact query was used? So that's a great question. If the injection was done in the URL, then yes. And depending on your logging, potentially if it's done in the body. In this case, it was done in the body. And by default, most like web servers do not log the body of requests, and that's for good reason, because the request bodies can be huge sometimes. If you ever upload a file, for example, right, to a site, that file is placed in the request body. So you don't want to log those, mostly because that's just going to be a heck of a lot of data in your logs. However, potentially you could do it if the log sort of extracts certain information. Also, if there are error messages being generated by the SQL server, that might have them as well. All right, so there are definitely ways that blue teams can detect SQL injection, but it really depends how good your logging is. Okay. All right, so we're going to right-click again. So this lab contains an SQL injection vulnerability in the product category filter. Okay, so one thing you got to remember about these labs, they are labs, all right? They are realistic in the sense they're all kind of based on real-world stuff, but they do tell you where to find stuff, all right? And that's just so you don't waste a lot of time searching for these vulnerabilities. But it's going to tell us that there's an injection vulnerability in the product category filter. The results from the query are returned in the application's response, so you can use a union attack to retrieve data from other tables. To construct such an attack, you need to combine some of the techniques you learned in previous labs. Well, we're just going to go in completely blind. It's fine. Database contains... So this is where we're going to actually ignore this for a minute, because this actually tells us that there's a users table, and it tells us there's a column, username and password, This just makes it easy mode. All right. We don't like easy mode. What we're going to do, we're going to use my cheat sheet. All right. And we're going to use these list tables and list columns features to figure out where the users are stored. All right. Even though we technically know where they are, we're just going to pretend we're going into this completely with no knowledge. All right. And we're going to retrieve all usernames and passwords and log in to the administrator account. All right. So we're going to do this again. I'm going to copy this because I'm currently in Firefox. I'm going to copy it here. Okay. So we're going to use, we're going to use tech gifts category. All right, so tech gifts category here. Let's go to proxy, filter, send to repeater. If I click send, always click send when you send something to repeater, just so you have, that's going to capture basically the response again. All right, by default, it doesn't send the original response to repeater. Okay. So let's do our basic SQL injection by putting a single quote. Oh, look, we got an internal server. Excellent. So that's usually a good sign of SQL injection. Doesn't necessarily mean SQL injection. But internal server error versus like a 404 is a pretty good sign. All right. So let's use the... I'm going to we'll use my cheat sheet here. Okay, so we're going to use the repair methods. Okay, so the first repair we're going to try is just this one. So again, you can just copy this. And remember, we want to replace this repair, okay? So by repairing, we are effectively we're appending it to the original valid value, right? Tech gifts with a valid value. Now remember, this is a space. And it's in the URL. If we sent this, this is technically an invalid request. What we need to do is we need to actually encode this. So you can do this by, in Burp Suite, selecting the space, or to be honest, selecting, you don't want to select the plus, but selecting this and doing Control U, and that's going to replace it with a plus. But that still gives a 500 internal server. Okay, so we're pretty confident that's not repaired it. So let's try this now. And so again, we're just going to replace the entire original repair with this. Oh, look, 200 okay. All right, well, that tells us a few things. This repair tells us it's probably one of these. It's definitely not MySQL. It should definitely not be MS SQL. But what we can now do is we can actually try some of these identifying variants. We try and identify what variant we're dealing with. So what we can do, we can actually just play around with this. Let's actually see if we can inject a comment, all right? So you see the pluses there. This is also a really nice feature of Burp, by the way. If you select this entire tech gifts thing here, then in the inspector, which sometimes is on the left, but I love it on the sometimes on the right, I default it to the left. So you can actually see here it's decoded the entire value. So you can see here we just have tech gifts with a single quote, a space, double dash, space, dash. All right. So let's see if this gives us a 200. It does. Excellent. This means we can play around and just comment out the rest of the query. Okay. So let's copy this. So I'm going to place this in here. All right, so this should be fine. We've got and 2hex equals 2x1 equals 1. Apply the changes. It's going to automatically encode everything. Send it. We get a 200 OK. All right, we know a 200 OK is valid, which means immediately we have identified this as Postgres. Okay. So we don't need to do any of this. We don't need to deal with Oracle or SQLi. Okay. So the other thing we need to do now, before we go on, we know this is a union injection. If we're dealing with union injections, we need to know how many columns we're injecting into. Okay. And that's because when you have a union injection, right? So basically, if we can inject a union, we need to match the number of columns in the left query, and we don't know what the left query looks like, right? This is all on the server. In this case, there are 3 in this example. So if I tried to just do a select 1, 2, this would fail, right? Because I'm trying to select 2 columns and merge them and union them with 3. So there are a couple of ways to figuring out how many columns there are. The easiest is to use an order by. And the great thing about order by, it'll take, generally speaking, a column name. So you could, for example, order by username. But what it will also do is it technically accepts column indices. So that means we can do order by 1. Okay? And that will order by the first column. We can do order by 2 and it'll order by the second. Now, if the columns, if there are only 3 columns and we try and order by 4, it's gonna fail. Okay, because it doesn't understand this statement makes no sense. We're basically telling it, hey, can you order by the 4th column here? Well, there aren't 4 columns. So when you're dealing with order by, what you want to do is start off, make sure that an order by 1 just works, all right? And then you just you increase the value. So let's try that now. What we're going to do here, we're going to do an order by 1. And again, we still need to do the comment. We get a 200 OK. That's great. That's exactly what we wanted. So we could just keep going up by, like, we could just do 2 here. We get a 200 OK. What I recommend, do some really stupid value. All right, let's just do 200. All right. Because we want to make sure that we get an error message when we go over the number of columns. And in most databases, there aren't 200 columns. All right. So my recommendation, once you've confirmed that an order by 1 works, we get a 200. Then the next thing to do, just go really insane. Choose a stupid value, 1337, right? Just to double check that we should expect to, and if you don't get an error, right? If you do 1337 and you don't get an error, that means either of 2 things. Either there are definitely 1,337 columns in this select statement, or we don't really have, or SQL injection is really gone wrong. All right, so it means one of 2 things. But you can always, for example, double this value and keep going up and just, until you hit a 500 internal server. All right, but let's say we know now that there are definitely less than 1,337. So what we can do, we can go a little less insane. We can do 10. All right. All right, great. So 10 still results in error. That means that there are between 1 and 10 columns in this select statement. Okay. So what we do now is we're just going to have it. So I'm going to have 10 because we know the value is between 1 and 10. All right, we get a 500 internal server error again. Exactly, binary search. So we have it again. We know it's between 1 and 5. Let's go to 3. Internal server error. Okay, well, this is great, actually. This means it has to be 2 because we already did 2 before. But yeah, there are 2 columns. Okay, we know that because 3 didn't work, 2 did. So we know here that there are 2 columns. Okay. So what we can do now is find, we can do our actual union and see if we can get just some dummy data. So we're going to do a union select, and I usually start by just doing 1, 2. So we know there are 2 columns. Apply the changes. We get a 500 internal server. That's okay. All right. All that means, in some databases, a 1, 2 will work. In others, it won't. And that's simply because we also need to match the type of the columns. Okay. So by type, an ID is, generally speaking, in most databases, an ID is an integer. The username and passwords are usually strings. Okay. So if we try and give an integer value when the column is expecting a string, sometimes that can error out. In some databases, it like MySQL is great for this, and I did a whole talk on it. But in MySQL, it will literally try and do the conversion for you from an integer to a string. Postgres doesn't do that. Postgres likes you to give it actual values. Now, one way around this is we can actually use null values. Okay, now null values, technically, Postgres is perfectly happy to have nulls for any column value. And so what we can do here is we get a 200 OK. Now, we don't get any data out because they're literally nulls, but that's okay. We know we can at least inject. And so what we want to do, the next thing we can try is try strings. So let's just do Tiberius here. And let's try NahamCon. And we'll apply the changes. Okay, so let's scroll down. There we go. We've got Tiberius and NahamCon, but we had to scroll down a lot, right? We had to scroll all the way down to the bottom to see this. And I'm really lazy, so I don't want to do this anymore. So we can use the trick I talked about, right? Technically speaking, we're giving this a valid value. Tech gifts is a valid value. What if we just give it an invalid value? What if we just, I don't know, spam something? Right? So now we're actually filtering. So we're making the first half of our union, right? The left side of our union is looking for a category that doesn't exist. So it's going to return 0 rows. And then our select is going to return Tiberius and NahamCon. So if we send this now, we don't have to scroll down much at all, right? It's actually, if we just render, it's right there. Okay. So there we go. So we have the data. All right. So now what we need to do, we know it's Postgres. We've already figured that out. So we need to enumerate, let's enumerate what current database we're in. So we're going to scroll down here. We don't really care about the version, but I guess we could try it. Why don't we do it? So what I'm going to do is replace the string NahamCon with the version function. And we're going to send it. And that's quite nice. That actually confirms we're definitely using Postgres. Okay. We just didn't have to do that, but it's fun too. All right, now Postgres is weird. It has the concept of databases and schemas. Technically speaking, in this instance, we need to use schema. So let's try and figure out what schema we're in. So again, we can just replace the version call here with current_schema. And we are in the public schema. All right, so we're going to keep track of this. So the schema is public. Okay, so again, we're going to go back to the cheat sheet. Now we're going to move down. We don't need to list the databases because we're going to assume that the public schema is where all the tables are. This is the current database we're in. So we're going to skip to listing tables. Now, there are two ways of doing tables. So two methods that I know about. We're going to select this first one. Okay, so we're going to select table name from PG tables where schema name equals schema name. All right. So actually what we need to do, we need to adjust this a little because we're in a union. So what we can do is we can copy table name here. And we're going to replace current schema here with, actually, I'm going to select the whole thing. We're going to replace current schema with table name. Okay. And then we're going to select all of this. And we're going to paste it here. All right. So we're technically union selecting the string Tiberius and the column table name from PG_tables where schema name equals. And we can type the word public here. Now, technically speaking, we could also replace this string with current_schema, right? If we wanted to, because that's effectively the same thing. But let's just put public there for now. So if we send this, there we go. So we actually have two things listed, the products table and the users table. So tables, we have products, and we have users. All right, well, we're after the user, right? We want to know what the administrator password is, or we want to know at least what we don't even know that it's the administrator. We're pretending. We don't know it's the administrator username. But so we want to know what the users table looks like because we don't know any information about it. So we need to list the columns. All right, we're in Postgres. Now I know one thing for Postgres about this. So what we're going to do, select the column name. I don't really care about the data type right now. If the column names are interesting, I might probe for data type. But let's for now replace this query here. So we're going to replace table name with column name. And we're going to go from information underscore schema.columns and copy all this, paste it there. So now what we need to do, table schema is still public, right? That's the name of the schema. Table name is going to be whatever table we want. And there's two tables, products and users. So let's use users. We send this now. There we go. Okay, so we have an email field, a password field, and a username field. Okay, so the users table is going to have an email, username. Perfect. Okay. So now we can just extract those columns, right? So technically speaking, we don't need this Tiberius string anymore because it would actually be really neat if we could have the username displayed here and the password below it. So what we can do now is we can say display the username, comma, password from the users table. All right. And there we go. We have the username and the password. So let's go down, copy this password. I'm going to make sure I don't copy the trailing space, but administrator password, log in, and that should solve the lab. And indeed it does. Okay. Curious why SQLi is an entry as a database. Isn't it used to interface with all the mentioned DBs? No. SQLite is technically a database format. SQLite is an interesting one. So all these databases are technically database servers. SQLite is not a database server. So the way SQLite works, it keeps its database in a flat file. You don't need a process running to run the database. What you basically do is in your program, you open up the SQLite file, and then you can query the file. All right. So there's no actual server running. And this is why, by the way, if we scroll up, this is why when you go to the list database sections, technically every single SQL, if you're opening an SQLite file, that's the database. You can't have multiple databases in an SQLite file. You can have multiple tables, but you can't have multiple databases. And so that's why when it goes, there's no point in asking the current database of an SQLite file. There's no differentiating between them. In a scenario where you're limited to only returning numerical data types, are there ways around this to extract strings, or would you fail back to treating it like blind SQL injection? So what you could definitely do is you could extract individual characters, and you could probably get a bit messy with it and use the you could that's a good question. You could probably use multiple unions to extract individual characters, but not like multiple rows, if that makes sense, and convert the characters to an integer and then display the integers. Like, for example, let's just say we wanted to extract administrator, right? You could extract the A, right, in this row here as an integer, and then the D here, and then the M here as an integer, using multiple union statements. But that's very messy. At that point, I would just use SQLmap. I'm sure SQLmap could do it. In a bug bounty, where to look for SQL injections? First, indicate the juicy parts. Is there any way to automate, or we just have to put payloads in every single parameter or cookie out there? Yeah, I mean, pretty much you have to at least put payloads into parameters. Dealing with WAFs, that's always going to be tricky. I unfortunately had to miss the last workshop, but I imagine there was some good advice on bypassing WAFs in the last workshop. But yeah, generally speaking, I would advise, you know, trying to it's not even necessarily spamming, just try different single quotes and double quotes in different parameters and seeing what happens. Will SQL injection work when parameterized statements? Parameterized statements, prepared statements, yeah. SQL injection is generally speaking mitigated by prepared statements in almost every instance I can think of. Have I used Gory? I have not. I can try Gory. Okay. Let's try some blind SQL injection now. So we're going to do blind SQL injection with conditional responses. I'm going to open this. Okay. We are going to copy it here. And let's actually read the lab here. Blind SQL injection vulnerability. The application uses a tracking cookie for analytics and performs an SQL query containing the value of the submitted cookie. The results of the SQL query are not returned and no error messages are displayed. Right? Basically, this is effectively saying you can't use union injection, you can't use error-based injection. The application includes a welcome back message in the page if the query returns any rows. All right. The database contains a different table called users with columns called username and password. Find the password for the administrator user. Okay. So because it's in a cookie, what that basically means, even though I loaded this page, I'm assuming if we go to this GET request here, we don't actually have the tracking cookie because it was set here. So what I'm going to do is I'm just going to refresh. And now if I look at this, I have my burp set to display everything back to front, by the way. Don't ask me why. I just like it that way. All right, so now we have a tracking cookie. Now we can go to repeater. And remember what I said, always send the request immediately when you go to repeater, because that way you know, okay, this is what the request is going to generate. It's a 200 OK. So first thing we can try, right? Just put a single quote. And now it might not look like anything happened. All right, so, you know, do you see any changes? I do a little bit. Well, the content length is changing a bit, right? So I wonder what's changing now. I know it told us, but we're going to pretend to be hackers, all right? Because we are hackers. So what we're going to do, we're going to go back to the original request. And I'm going to right-click here and go send to comparer. And then I'm going to click forward. So this is the request where I injected. Send to comparer. Now we go to the comparer tab. Let's click on words. Okay, so it's highlighted. Yeah, there is a difference, right? Orange means modified. If we click sync views, now when I scroll in one of these panes, both of them scroll. Oh, look. Deleted. So the welcome back message is deleted, which means our SQL injection caused some kind of error, probably, and because of that, the welcome back message disappeared. So let's see if we can repair this query and get that welcome back message back, all right? So what we can actually do here, if we type welcome back into this search, right? One cool feature about Burp is if you click on this cog here and click auto scroll to match when text changes, if I click send again, it's going to automatically scroll down to this welcome back message for me. And now if I put a single quote, it's not going to scroll because the welcome back message does not appear. Okay. So let's try just repairing the usual way, all right? So I'm going to put a space and a single quote. Now, technically speaking, you don't actually have to URL encode these. And it might actually look nicer if we don't. So let's try it. So we get a 200 OK. Obviously, we were expecting that, but we don't get a welcome back message. All right. So let's try replacing that space with 2 pipe characters. And we get a welcome back message. Excellent. And what we can also do is we can double check and see, hey, if I can just do this and comment out the rest of the line, does that get me a welcome back? It does. Excellent. Okay. So let's again figure out, using the cheat sheet, what database we're currently using. All right. Well, we know it can't be MySQL and it can't be MS-SQL. Again, that's great. We can skip ahead because obviously the plus as a space didn't work, and MS-SQL doesn't support the syntax where two pipe characters concatenate. Okay, so we can skip ahead to Postgres. We can just copy this Postgres payload here. And we know this is a valid value. That's what we want to inject into. Oh, perfect. It's Postgres again. I think most of these are Postgres. This is the only annoying one. All right, so we know it's Postgres. Excellent. So here's the issue, though. This is blind, which means we do not get any information back. Okay, whereas before, with the union, we could just extract the version, right? If we put version query into our union, right, the version would appear down here. That doesn't work anymore. But what we can do is we can change this to, for example, and1 equals 1, right? And we get the welcome back. If we change this to and1 equals 2, we don't get a welcome back message. All right. So what we know is if we put a conditional here that's true, we get a welcome back. If we put a conditional here that's false, we don't get a welcome back. And so this is the nightmare that is blind SQL injection. The way you do anything with blind SQL injection is you ask it a series of yes or no questions, and you learn either way. If you get a yes, it's usually great. If you get a no, that also means something, right? It tells us some information. And so what we're going to do is, this is why it's called Boolean, by the way, Boolean blind SQL injection, because basically it's a true or false. We're asking it true or false statements, and based on the response, we can extract information. Okay, so for example, let's say that we want to get the length of the current schema, all right? Because we can't just start guessing what the current schema is. Okay, technically, we guess we don't really need the current schema, but let's figure it out anyway. We can't extract the current schema. We shouldn't start guessing. But what we can know is, hey, how long is the current schema, right? So the current schema is basically the database name. All right, so we're going to go down here. Length in Postgres, count the number of characters is just, the length function. So what we can do here is we can say, hey, and the length of the current underscore schema, right? And we can do a comparison. Now, what we want to do first is make sure that our true or false is still working. So what I generally do here is I do greater than 0, right? The current schema should definitely be greater than 0. So when we issue this request, we should get a welcome back message. And we do, right? But what we definitely want to try now is make sure that when we give it a false, we still get a false back. All right. So we know it's greater than 0, which means it cannot possibly be equal to 0. So if we send that, good. All right. We didn't get a welcome back. Okay. So we know now that the current schema length is greater than 0. So we can start playing around with it. So let's say, is it greater than 10? Okay. We didn't get a welcome back. That means it's not greater than 10. So we can again have the value. Let's go 5. Is it greater than 5? Oh, it's greater than 5. So now we know it can't be equal to 5. So we know it's either 6, 7, 8, 9 characters long. All right. So let's just choose a midpoint. Let's go 7, right? It's not greater than 7. Okay. So is it greater than 6? It's not greater than 6. All right. Well, we knew it was greater than 5, but it's not greater than 6. So does that mean it's equal to 6? Yes. Okay. So we could have just started counting. We could have gone, hey, is it equal to 1? Is it equal to 2? Is it equal to 3? Is it equal to, right? But, that's kind of silly. Using a binary tree like search like this is much faster generally. Thanks, Mr. Pre. Yeah, I'll definitely improve the cheat sheet. What do you use to proxy your connection to Burp? So actually, Burp these days comes with an open browser functionality. So this is automatically just proxied. And this also handles all of the built-in TLS cert stuff. Okay, so we know the length is 6. So can we figure out the characters of this schema? Well, yeah, we can. But we have to do it one by one. So we have to use the substring function. All right, which in Postgres is substring. So what we can do, we're gonna replace length with substring. Current schema. Now it's the substring functionality, start and length. Okay, so the start is basically the index, and everything usually indexes from 1. Okay, so if we just want to extract the first character from foobar, right? If we just want to get the F, we would start at 1 and we'd have a length of 1. So what we need to do is do 1, 1. Okay. Now, we could just start doing this, right? We could just say, hey, is it equal to A? Is it equal to B? But again, that's pretty slow. And remember, you can't generally just do stuff like this. You can't do greater than comparisons with characters, right? But what you can do is you can convert characters to integers. So let's say we use this ASCII function, all right, in Postgres. So what we're going to do is we're going to surround the substring. The substring is going to return 1 character. We know that. So we're going to return the ASCII value. And now what we can do is, because we know this is now a number, we can do, well, is that greater than 0? Yes, it is. Perfect. Okay. So this is where we go to the ASCII table. So we're going to go to the ASCII table. Let's just blow it up a little bit. All right, we can make some assumptions here. So the assumptions I'm making are that the values of tables are in the ASCII table, right? So I'm assuming that nobody's named anything after Unicode here. I could be completely wrong about that, right? Maybe there's some Unicode, but we can figure that out if it comes to it. I'm also going to assume that these tables are going to be between, like, they're going to use the characters in this range, right? So there could be a space, and they could all go all the way up to a tilde character, right? So my general approach to this is, okay, well, we're going to use the binary tree approach. Let's have the search space. And look, amazingly, the O, the capital O, is roughly in the center of this search space. So what we're going to do here is we're going to say, hey, is this first character greater than the ASCII value? Remember, you have to still convert to ASCII. We're gonna be comparing numbers here. Is it greater than the ASCII value for a capital O? Yes, it is. Okay, what does that mean? That means that we've narrowed our search space from here all the way to here. So let's have that search space again. That probably puts us right around here. So why don't we try an F? Okay, it's greater than an F. So again, we're going to have our search space. We're going to go from F to a tilde. Let's say it's an R. Okay. There's no welcome back. That means this is a false statement, right? It's not greater than an R, which means we're between an F and an R. Well, technically, we know it's greater than an F. So it could be a G, and it could be an R tilde, okay? So it can go from a G to an R. Let's go for an L. So again, we still want to use greater than. It is greater than an L. So we're between an M and an R. Let's go for a P. Not greater than a P. Okay, so we're between an M and a P. It could still be a P. Let's go for an N. It's greater than an N. All right, at this point, we can basically go, hey, is it greater than O? It is greater than O. So it is a P then, right? Because we knew it was not greater than a P. It is a P. Hooray! We have extracted the first, I mean, we knew the schema already, right? But let's just say we didn't know the schema. We've extracted the first of 6 characters of the schema name. Okay. Do you understand why we never do this by hand now? So we could technically keep going by this. What we will do, we're going to do 2 things. Firstly, we're going to use the fact they've given us the hint here, right? They've told us there's a users table. They've told us there's a username and password, and we know that we want the administrator user's password. So what we're going to do is we're going to cheat a little bit. We're going to use brute force, and we're going to basically brute force the administrator's password using Turbo Intruder. All right. So the first thing I want to do, though, we want to figure out how long the administrator user's password is. Okay. So what we can do here is we can just do, hey, what's the length of the password? Oh, sorry, hang on a minute. I need to do a we need to do a subquery. We need to do select length of password from users, where username equals administrator. All right, so this subquery is going to select the length. It's going to return the length, and we're going to say, hey, is it greater than 0? Okay, it is. Perfect. Is it greater than 10? It is. Is it greater than 20? No. Okay. It's greater than 15. It is. Greater than 17. It is. Is it greater than 19? Okay, so it's equal to 20. So we know the password is 20 characters long. So now what we're going to do, we're going to use substring again. And we're going to select 1, 1. Right, we want the first character of the password. We are going to send this to the ASCII function. So we're going to wrap this substring with the ASCII function. We're going to wrap this, our guess, right here with the ASCII function. And let's actually just do, is it greater than a space? Because that should always be true. It is. Okay, perfect. So we have a true statement here. So let's just replace it with A. Okay. So now what we're going to do, we're going to send this to Turbo Intruder. And in Turbo Intruder, what we want to do is we want to iterate 2 things. We want to iterate this value, which is the position. Okay. So we're going to put a %s here. And we want to iterate this value, which is the guess. And I have basically a script already, but let's just go to basic here. What we need to do, this is Python code, by the way. So I'm just going to import string, the string library, and we're going to write some code here. So for letter in string.ascii underscore letters plus string.digits. All right, so that's just going to combine all the letters with all the digits. We're going to iterate over that, but also what we want to do is iterate over numbers outside of this. So what we can do here is we can do for number in range 1 to 21, right, going from 1 to 20. 21 is never included. So we need to tab that in. So basically, yeah, the first thing we're iterating is over this. Second thing we're iterating is this. So we need engine.q and then take out this from the original payload. We need to pass it a list, and the list is going to contain number and letter. Okay, so that just comes with those 2 for loops. And then what we want to do here is we want to change how we handle the response. We're only ever interested in a request if it contains the welcome back message. All right. So in this case, what we want to do is we want to say, hey, if welcome back in request.response. then we're going to add the request to the table. And hopefully this should work. We're going to try it. But hopefully what's going to happen, we click attack, engine's going to warm up. It's going to start basically iterating through every single possible letter. And here we go. It's already found the first character is an F. The second character is a V. So maybe I'll start writing these down. So we've got an F followed by a V. We have a Z. We have an X. And after we extracted this, you'll see how slow it is. We would just use SQL map and it'll show you how fast it can actually be. It's still slow because it's Boolean blind injection. But, you know, it's faster than this. Okay, we have 5 and then I. Remember, there are 20 characters. We've got 8. Now we've got 9. Are there any questions while we do this, bud? Get your questions in chat. That's why we limit requests a minute. Exactly, yeah. So we are also coming up on the hour. I'm not sure if NahamSec's still in chat, and if he wants to... If I need to cut off at the hour mark, then absolutely we can. Otherwise, we could technically do another lab, which is the error-based lab, but absolutely happy if you want to end the whole stream.
I'm gonna just join really quick and leave that up to our chat. Let me actually push myself to the side so your screen is still visible. But I'm gonna leave that up to the chat. Let me see how I can do this. Oh, you're not using your camera. Chat, what do you think? Do you guys want to do one more? 2 more? I just want to kind of engage the audience a little bit really quickly. I'm here. I'm listening to you and multitasking and answering CTF questions. So,
all right. So
tips. All right. I'm gonna maybe we can do 2 more. Does that sound okay?
I've got one more plan, so we can do. Actually,
Okay,
I guess we can do 2, but yeah, 1 or 2 is fine. Yeah.
1 or 2 more. All right. I'm gonna go back on mute and let you take it.
Yeah, of course. Okay, I think I messed up on one of these. Let's just see. F, V. I maybe got them out of order. Did I get anything? Yes, 17 didn't happen. Look. Okay, so 17. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 was the B. So we're missing obviously something failed here. So what we can actually do, this is actually pretty easy to solve though. What we can just do is start the range. We'll go from 7 to 8. All right. Sorry, not 7 to 8. What am I talking about? I can't count apparently. We need to go from 17 to 18. So sometimes, yeah, this is the issue when you're just spamming a server. Sometimes the request might not come back. There we go. We're going to see. So administrator. And there we go. We're logged in. All right, so let's see how we would solve this with SQL map. So it was in the tracking ID, right? Yeah, tracking ID here. So the first thing you do, obviously, get a request. This is the request. We're logged out completely. Let's just copy it. So I'm just going to do SQLi.http. I'm going to paste it in here. Okay. Now, when you're doing the SQL map, giving it a whole request like this is honestly the best way of doing it. If you guarantee all the headers are going to remain the same, and SQL map's not going to add its own headers like user agent header, right? But also it means you can mess around with the file a bit better. If we want to inject into a cookie, now usually you can't inject into a cookie in SQL map unless you're, I believe, running level 2 or level 3. But if you put an asterisk here, it should just work. So what we're going to do is just put an asterisk there. I believe I have a few. Yeah, I have a few aliases, but honestly, my aliases are pretty much just answering the default questions. I just have threads set to 10 as well. So what we're going to do, we're going to SQL map. We're going to use -r, which is the request file. Okay. What we're going to do, because it's going to assume HTTP, not HTTPS, we need to force SSL. Okay. Threads is already set to 10, technically, so we're fine. But to help it along, because we know what kind of injection we're dealing with, what we're going to do is we're going to set the database management system to Postgres. All right, that is going to effectively remove all the non-Postgres queries. Okay. And the other thing we're going to do is we're going to tell it the technique to use. And the technique is just Boolean-based blind. Okay. So what we're going to do, we're going to see what SQL map does. It's going to ask, do I want a custom injection marker is found. Do you want to process it? I'm going to say yes. And it's going to go off. And in the background, if you set the -v value to something else, so like 3, it's going to show you what's going on. But we don't need it. We don't need to worry about that. It has indeed found this cookie Boolean based blind. All right, it shows you how it's confirmed it. The back end is Postgres. It's confirmed that. Okay, that's awesome. So now what we can do is we can start enumerating. Now, I'm going to open up a new window. In SQL map, if you do -hh, it will show you all the lovely options. And the best part is going to be this section here, enumeration. So you don't want to do this. If you're dealing, actually, you never want to do this. Like never run -a, especially not in blind, but honestly, never anyway. So we could extract the banner, but that's going to take a while. Let's extract the current DB. Let's just do that just to show you how it's done. So the great thing about SQL map, once you've run SQL map once and it's found something, as long as you referencing the same request, it remembers everything. All right, so it doesn't have to go and re-exploit this. It's already discovered it, so it's going to know exactly how to use this this blind SQL injection to extract data. So all you need to do, if in your command line, right, is you need to just press up and then append some enumeration command. So in this case, current -db. All right. So, and remember, when I do this, it knows immediately how to exploit it. And I'm going to say, yes, we still want to use this. See, it already discovered it. And the awesome thing is, it's discovered it's 6 characters long. And look how quickly that took. All right. So it automatically extracted the public schema. Okay. Now, we want to enumerate the current tables, all right, that are in this schema. And so what we do is we say, hey, we only care about this current database. All right, database schema. Again, Postgres is weird. It uses schema and database sort of flexibly, but the database is public. Okay, we want to enumerate the tables of this database. Well, how do we do that? Well, there is luckily this tables option here, and because I've told it all we care about is the public database. It's not going to try and enumerate any other tables. If I just ran. Right, if I just ran --tables, it's going to try and enumerate all the tables in the entire database server, including all of the tables in the information schema database. All right, we don't want that. What we want is all the tables in the public database. Okay, so we'll try that. Again, we just have to press enter. It knows the public database. It's got that. It's going to fetch the number of tables. It's figured out there are 2. It's extracted the length. So this table is 8 characters long. It's got it tracking. This table is 5 characters long. It's users. Okay. So again, well, we care about the users table, right? We don't really care about tracking. So again, we'll go up. We'll take out the table option. Now, you might have guessed it, right? -t. for table. Which table do we care about? The users table. Okay, so what information do we want to extract from the users table? Well, probably need to know the columns, right? And luckily there's a dash columns option. So let's just do that. Yep, we're going to process that marker again. Okay, so it's figured out there are 3 columns. The first column is 5 characters long, and it's email. Second column is 7 characters long. Oh, sorry, this is the type. My apologies. So it figures out the type as well. So the type of the email is a varchar, right? Variable character. The password column is also a variable character. And this is the final column, 8 characters username. And presumably it's also a variable character. Awesome. Okay. Well, so now, realistically, we don't really care about email, right? We just care about username and password. So we can specify, okay, well, the columns, -C, capital C, we care about our username and password. Just separate them by a comma. So how do we get the information out? Because that's what we want, right? Well, dump. That's all we need. We just need to dump these columns. So if we do --dump, press enter to accept that. So what it's going to do, it's going to start extracting. Okay, so it says, okay, there are 3 entries. The first entry is 20 characters. I think it's doing the password column first. This is 6 characters. I assume this is, there we go, it's Carlos. Another 20 characters. This is another password here. But what it's doing in the background is it's doing that binary search. All right, it's not just brute forcing like I was. It's actually being clever. It's figuring out. It's what we were doing before. It's figuring out the range of the characters involved, and it's doing a binary search. And there we go. So we have all 3 users, and indeed, if we copy this, it's the same as before. Any questions about this? Okay. I'm going to assume there aren't any questions, so that means we can go on to the last one. The last one I had prepared for you guys is visible error-based SQL injection. We should always test manually, or we can use tools. Do both. I think it's better to manually try and find or identify potential SQL injections, and then you can use tools. Tools definitely help. But the issue with a lot of tools is they're not perfect, and oftentimes you can better enumerate things using manual methods than you can using than tools in terms of like discovery, initial discovery. Okay, so let's have a look at this. This visible error-based SQL injection uses a tracking cookie. Okay, and again, we have a table we need to extract username and password. Perfect. So let's just refresh, make sure we have that cookie set. Let's close down Turbo Intruder. And we're going to go here. Okay, remember, always send it. So the tracking cookie is here. So let's just do a single quote. We have an internal server. Now, this was a visible error base. What does that mean? Well, if we click render, we get this lovely message. Okay, so we scroll down in the window. Unterminated string literal up started at position 52 in, and then it lists SQL select all from tracking where ID equals this. So there you go. There's our little extra single quote. All right, this is an error message. What do we do with error messages? We search for them. So let's just put this into Google and see. Oh, look at that. Instant hit. Postgres. Again, we're always with Postgres. But this means we don't have to check what database we're using, okay? So it's Postgres. But here's the thing. with error-based SQL injection, if you can't turn it into a union, generally speaking, union-based injections are the superior type. All right, error-based comes after that. So with error-based, the issue is we can extract information from the error messages, and we can be sneaky and get information in the error messages. Okay, but what we can't do something like, we can't be sneaky and do, hey, and current schema equals 1 or something, right? We can't do this thinking that current schema is going to get turned into something. All right, if we do this, current schema is there still. Okay. So the trick with error-based injection is you need to extract the information first and then use it in some way that causes an error. Okay. And if you go to my cheat sheet, you can see so many examples. If we scroll down, there is an entire section on error-based exploitation. The following injection should cause a database error and return the version information of the database variant within the error message. Okay, so let's go down to the Postgres section here. So these might look complicated, right? And they kind of are. But realistically, what's happening here? These honestly all do the same thing, just different ways. We're assuming, right, that a version string that contains the word Postgres, right? It's a string. What we're doing is we're making sure it has some weird characters in it, right? In this case, tildes. And then we're trying to just turn it into a number. And you can't turn tildes into numbers. All right. You can't turn multiple tildes into numbers. Okay. So effectively, what we're asking Postgres to do is turn a string that is literally not a number into a number. That's going to error out. And as part of that error message, we should get the original version text. Okay. So let's just, honestly, this is probably the easiest one. Let's do this one. So what we can do here is paste that in. And then hopefully, there we go. Lovely. Look at that. So the version function has been converted into this string. And invalid input syntax for type integer. Basically, we told Postgres this was an integer. It's clearly not. And Postgres has just spat out this entire thing as part of the error message. What did you mean by level 3? Oh, sorry. Yeah. So in SQL map, there are different levels, 1 to 5 of the tests. So 1 is pretty basic SQL injection. That's the default. 5 is really, really complex. But also certain things don't get tested at level 1 by default, like cookie values don't get tested at level 1. I think it requires level 2 or level 3. But generally speaking, level 1 is fine for most basic SQL injections. Okay. So, yeah. Well, we can actually, even though we've been told, again, right, where the users table is and everything, let's just try and figure it out, right? So we want to know what the current schema is. Let's do current schema. So we can go here, and instead of the version, let's just do current schema. It's public again. Lovely. All right. Can we then list the tables? So we probably want to do this. Let's try public. This might have another error message, actually. This might. Okay, so this is the interesting one about this, actually. So this one, it limits the amount of data you can actually put into this, into this value. So we actually might have to get a bit experimental here. Syntax error at end of input. Let me just do that. This wasn't happening earlier, so I wonder what's... Let me just try something. Oh, that's not going to work. Okay, so I think maybe we can't actually... All right, so that might be why they told us to use the table. So I think the issue with this one actually is... Yeah, I'm remembering now, actually, yeah. This one, I think you can technically do it. It just requires a really complicated setup. Like, I think you have to do... I think you have to use pipes to concatenate. Yeah. All right. Well, we'll go back and we'll just assume we know exactly where everything is. So yours, obviously, this is a big issue with some SQL injections where you can't necessarily extract much information because literally the query you have to use is too long. All right, because the value is getting concatenated, or it's getting truncated, I should say. All right. So, like, for example, if we wanted to get column data out, we'd have to use this long query, potentially. So that's one issue you can run in with SQL injection as well. But I think what we can do, if we can just guess that we want to select the username from users and we limit 1 or something. There we go. Yeah. So we can definitely extract username and passwords here. All right. So invalid input syntax for type integer. Again, we're extracting the username from the users table, comparing it. Well, we're casting it to an integer, and we're getting back this error message. So again, we can do password, and there's the password. So we sign in now. There we go. But ordinarily, that wouldn't be an issue, right? There wouldn't be this limitation. I think there is a way. I think maybe on stream I did it once. I'm not recalling this one. But yeah, you can actually. Usually, these are fine for extracting information. And again, you would just go to this cheat sheet, scroll down to the payloads here, and choose whichever one you wanted. Okay. The key thing, though, is you have to use one of these payloads are very special because what they do is they extract the information you want first, and then they pass it to a function which is going to cause the error message. All right. So you have to kind of think of it like in reverse. So you can't just cause an error message and think that it's going to spit out the information. You have to use the information in a way that's going to generate an error message for you. So these, by the way, I didn't come up with most of these. A lot of these are just found in the SQLmap source code, right? SQLmap knows how to do this. So a lot of these are just taken from SQL. Okay, that was all I had really planned. So yeah, that's kind of cool. I think we went 2 hours. Hopefully you guys managed to follow along. Again, this is available on screen, tiberius.com/SQLi. I will definitely be updating it. I can also share the slides. I'm sure NahamSec can put the slides somewhere. But yeah. I hope that was enjoyable. I hope you learned some stuff about SQL injection. Now you can go forth and hack all the databases.
Thank you so much, Tibbs. Thanks for doing this and putting this together for all of us. Let me just add you on here really quickly with me since there's 2 of us. There we go. But yeah, thank you so much. You know, you were the last one, and I think we ended the conference on a high note with you hosting this. So thank you so much for everybody that is looking to follow along. I know you do some really, really cool streams. I'm going to just put your username on here. Tiberius does, I got to just make this right, actually. OX
Yeah, I was going to
Tiberius.
say 0x Tiberius on most platforms.
Let me do that. Sorry about that. It is OX
That's good.
Tiberius. Make sure you follow him. You do mentorship Mondays and the web app Wednesdays. I sometimes popped in and looked at your stream. I enjoy watching them myself. So anyone watching this that you want to continue learning with Tiberius, make sure you check him out. I know you have some content on YouTube. You have some really cool stuff on Twitter. Your website is a gold mine of cheat sheets, and your stream is phenomenal. So if anyone's watching this and they want to follow along, make sure you go to the right username right here, OX Tiberius, on all social media platforms. One last question for people that want to get good at SQL injection. SQL, not SQL. What do they do?
Yeah, well, I think honestly the Portsfigure Web Academy is really good. It
Yeah.
teaches so many different forms. There are tons of content we didn't go over today. There's I think it's like 13 different SQL injection labs. So that's good. I'm coming out with a course at some point which teaches it as well. So
Nice.
yeah, the cheat sheets are effectively from that. But yeah, step 1, pronounce it like Tibbs. Exactly. That's how you get good.
All right, awesome, dude. Thank you so much. Thank you so much for doing this, man. I really appreciate
Yeah,
it.
anytime. I love it. I love
Chat, please give it up for Tiberius being here again. Thank you so much, dude. And hopefully we'll see you at the next NahamCon.
Awesome. Thank you so much, man.
Yeah. All right, chat. That was it. If you're watching this live, thank you for sticking around throughout the whole conference. I know it was a long day. I think tomorrow we're going to be doing as long as today. If you're watching this still and you want to, maybe you're watching this offline in the next couple of hours, just remember we're going live again at 9 a.m. California time, Pacific Standard Time. We will be live at 9 a.m. with a bunch of talks, and this is going to be day 2. If you're playing the CTF, go on and make sure you look at the challenge that we're doing. We're doing a really cool CTF mission with integrity. There is a ton of prize just for that one CTF level, but if you want to just do the Jeopardy style CTF, there is a ton of prizes. I think $2,000, $1,000, and $500 for the top 3 teams on the CTF. So go play around. There is another maybe 21 hours left. So if you're watching this and you want to go score some money, 21 hours left on the CTF. All right, that's it for me. Chat, thank you so much for being here. I really appreciate it. Thank you so much. If you're here watching this, drop me a bye. Say goodbye for the day. We're going to close it out, and I will see you all at 9 a.m. tomorrow, same time as today, and can't wait to do that tomorrow. See you all. Bye.